In the stillness of a clear night, you gaze up at the stars scattered across the sky. The Milky Way arches overhead, a faint river of light flowing through the darkness. The air is quiet and calm. As you look deeper into the night, beyond the shimmering stars, you sense the vastness of space stretching out, silent and mysterious. High above, the universe lies in gentle slumber, a tapestry of countless stars and deeper darkness between them. Each star above is a messenger from the past. The light you see tonight left those distant suns many years, or even many millennia ago. Some of those stars may have already lived out their lives and vanished, ending in dramatic explosions that our eyes have yet to witness. Yet their final light is still on its way, traveling silently across the darkness. It's possible that one of those shimmering points has already faded into darkness, its star gone, transformed into a dense remnant we cannot see. In the sky, it appears unchanged, a tiny beacon of light, but beyond our sight, a new dark presence now lingers where that star once shone. The cosmos holds these secrets quietly, the ghosts of stars that have died, and the black holes born from their death, hiding in the velvet night. Out in that darkness, far beyond our sight, something hidden drifts through the cosmic night. Invisible to our eyes, it moves without a sound. Among the stars are places where light itself has vanished, where a great mass lies cloaked in shadow. These are black holes, silent guardians of the night, scattered throughout the galaxy. They do not shine or glow. They blend into the ebony backdrop of space. Yet their presence can be felt in the subtle dance of starlight and gravity. Tonight, under this peaceful sky, we journey beyond Earth, into the tranquil depths of space, to explore the secret lives of these mysterious dark wanderers. Drifting weightlessly, we leave the comfort of our home planet behind and glide outward into the starry expanse. The Earth becomes a tiny blue glow in the distance, then vanishes from view, and all around us the stars grow clearer and brighter. We slip beyond the farthest reaches of our solar system. Our sun dwindles to a mere speck behind us, just another star in the sky. Overhead, the misty band of the Milky Way becomes ever more vivid, a gauzy river of starlight guiding our path. We feel the calm of the cosmic void, a deep, serene silence that has lasted for eons. Amid this quiet, we become aware of the hidden giants in the dark, the black holes that lurk unseen. Though invisible, their gravity subtly shapes the movements of stars and gas, weaving them into the grand cosmic tapestry. We sense them indirectly, like faint whispers in a quiet room. They are there, patiently existing in the dark, as they have for ages. Our journey begins with one such whisper in the darkness. To understand these silent behemoths, we must first witness how one is born. Among the millions of stars spread across the galaxy, a few are destined to give birth to darkness. It is to one of those stars we now turn our gaze, to watch the gentle drama of a star's final moments and the quiet birth of a black hole. Far away, in a quiet corner of the galaxy, a lone star is reaching the end of its life. This star is enormous, dozens of times more massive than our sun. For millions of years, it has burned brilliantly, pouring out light and heat into the surrounding space. In its youth, it blazed with a fierce blue-white glow, but now its long life is drawing to a close. Such a massive star lives fast and will die young. Millions of years may seem an eternity to us, but for a star of this size, it is a brief, brilliant existence. The star has begun to change as it ages. It has swollen to many times its original size, and its once steady light has grown unstable, flickering slightly as its fuel runs low. Deep within its core, the nuclear fire that sustained it is dwindling. The core has become heavy, burdened with the ashes of spent fuel, and it can no longer hold up the star's immense weight. The star has grown old and weary, its radiant vigor giving way to a looming collapse. It now stands on the brink of a tremendous transformation, the final act of its shining existence. In the vast silence of space, the star's last moments arrive. Without warning, the core can no longer withstand the relentless pull of gravity. In a heartbeat, the core implodes inward, crushed by its own tremendous weight. The temperature and pressure at the center soar far beyond anything the star had known in life. As the core collapses, the star's outer layers rush inward too, only to be hurled violently back out. In one magnificent instant, the star that quietly shone for eons erupts in a spectacular farewell. A supernova blossoms in the darkness, a titanic explosion of light and energy unfurling into space like a celestial flower. The dying star's brilliance suddenly rivals the brightness of an entire galaxy. For a brief time, it outshines all the stars in its neighborhood combined. The blast wave races outward, carrying the star's outer layers with it. Day turns to night, and back to day, in the blink of an eye, as an expanding shell of gas and dust floods the surrounding space. The eruption is as beautiful as it is powerful, like a cosmic fireworks display, casting blue and silver and crimson hues across the darkness. From a safe distance, we watch this cosmic spectacle unfold in eerie silence. In the vacuum of space, no sound accompanies the burst of light and color. One moment, the star was a brilliant beacon. The next, it has burst apart, filling the sky with a radiant cloud. The expanding shell of the supernova billows outward in great waves and wisps, sculpting intricate shapes in the surrounding space. Iridescent filaments of stellar material spread outwards like petals on the cosmic wind. It is a beautiful and haunting sight, transient and sublime. Slowly, over days and weeks, the extraordinary glow begins to fade. The once mighty star has cast off its shining outer form, and its remnants continue to drift outward as a glowing nebula. Only a faint ember of the star's former glory now lights this corner of the galaxy, and that too is dimming with time. The climax of the star's life has passed, and what comes next emerges from the fading light. Yet, in this moment of destruction, new beginnings are also forged. The stellar material flung into space is rich with elements the star created in its lifetime. Elements like oxygen, carbon, and iron. As the debris spreads out, it will seed the surrounding cosmos with these ingredients. Someday, far in the future, that material may coalesce into new stars, new planets, or even form the building blocks of life. In this way, the star's violent end will give rise to fresh possibilities in the galaxy. As the supernova's light finally wanes, a deep darkness settles where the star's heart used to be. In the core of the chaos, something new has formed. The core of the star collapsed so completely that it has created a black hole. All the mass of that giant star's center is now compressed into an incredibly small space, perhaps only a few miles across, about the size of a city, yet containing more mass than our Sun. It is almost impossible to comprehend. An object so dense that a single teaspoon of its material would weigh billions of tons. This newborn black hole is utterly dark. It emits no light or heat. In the aftermath of the brilliant explosion, it sits quietly at the center of the expanding debris cloud, invisible, like an ebony pearl hidden in a veil of stardust. For a while, the region around the new black hole remains aglow with the aftermath of the supernova. Shimmering clouds of hot gas and dust swirl and billow outward, cooling and growing fainter as they expand into the depths of space. Some of that ejected material may briefly fall back toward the black hole, drawn by its gravity. A portion of the star's remnants might even form a transient disk spiraling into the dark center, disappearing forever beyond the event horizon. But most of the stellar debris continues to drift away, carrying with it the star's last light. What was once a brilliant sun has become a delicate nebula of colorful gas, expanding and fading into the surrounding void. And at the heart of that nebula lies the black hole, silent and unseen amidst the glowing wisps. Eventually, the expanding gases thin out and the nebula dissolves into the starry background. The supernova's remains become a tenuous memory, a faint haze of atoms scattered across light years. Darkness fully returns to this region of space. Where once a radiant star thrived, now there is only an absence of light, a persistent, invisible gravity where the star's core used to be. The black hole remains, solitary and calm amid the emptiness, marking the spot where a star's life transformed into a new kind of existence. In this gentle aftermath, we have witnessed the birth of a black hole, a profound silence and stillness following the grand finale of starlight. What was an ending for the star is the beginning of a new mystery in the cosmos. Now all is calm around the newborn black hole. In the patch of space where a star once shone, there is a dark, invisible sphere. What exactly is this strange object that has taken the star's place? From the outside, a black hole gives no clue of its nature except through the pull of its gravity. It is as if an enormous mass has suddenly vanished from sight, leaving behind only its gravitational presence. We cannot see the black hole directly, but we can feel it by how it tugs on anything nearby. It is a region of space where gravity has become overwhelming, creating a one-way door in the fabric of the universe. Surrounding the black hole is an invisible boundary known as the event horizon. This is the point of no return. If any object or beam of light drifts too close and crosses that boundary, it will be pulled irretrievably inward, lost to the outside world. Imagine a sphere around the black hole. Within that sphere, the pull of gravity is so strong that nothing can escape back out, not even light, which moves faster than anything else in the universe. For something that falls in, the event horizon is the last place it can still, in theory, turn back. Once it passes through, the outside universe will never see it again. It's as if that object has slipped beneath the surface of a dark sea, vanishing from view. It's as though space itself has given way at this boundary, plunging inward. One might picture a black hole as a bottomless well in the fabric of space, or a deep whirlpool in a still sea. Anything that drifts too close gets pulled in, disappearing beneath the surface. The event horizon is the edge of that well. the threshold past which there is no escape. At the event horizon, space and time themselves are distorted in extraordinary ways. If we were to watch a traveller getting too close to the black hole, we would see them slow down as they approach the horizon, their movements becoming ever more gradual, until they seem almost frozen at the brink. Time appears to stand still at that boundary from our distant perspective. This strange effect makes the black hole's edge feel like a suspended moment in time, adding to its aura of mystery. It is a consequence of the black hole's intense gravity warping time itself. To an outside observer, it's as if the universe has paused at the threshold, reluctant to let anything slip away. The edge of the black hole holds its secrets behind a veil of slowed time, enhancing the eerie stillness of this cosmic abyss. And what lies inside that boundary? Deep within the black hole, at its very centre, we find what can only be described as a heart of darkness, the singularity. This is the crushed core of the star, collapsed to an almost infinitely dense point. All the remaining mass of the star has been squeezed into an incredibly small volume. The gravity here is beyond anything we can truly fathom. In this heart of the black hole, our current understanding of physics breaks down. It is a mysterious singularity, a place where the normal rules no longer apply. We cannot observe it directly, or peek behind the curtain of the event horizon, so the singularity remains an enigma. We only know that all the mass of the star is concentrated there, hidden forever from view, a heavy, silent heart at the centre of the black hole. Some scientists speculate that at this central point, space and time may curl into something we barely understand, or perhaps give way to a new realm entirely. Others even dream that a black hole could be a gateway of sorts, a tunnel through space or to another universe entirely. These notions are purely imaginative, born from our desire to peek behind the curtain. In truth, the singularity is an unsolved mystery, locked away in darkness. Yet, despite its ferocious gravity, a black hole is not an active destroyer unless something comes very close. From a distance, the black hole's gravitational field is no more threatening than that of the star that originally birthed it. If our Sun were replaced by a black hole of equal mass, the Earth and other planets would continue to orbit almost as if nothing had changed, though our world would be cast into darkness. We would feel its gravity, just the same as before. This means black holes are not cosmic vacuum cleaners, indiscriminately devouring everything in their galactic neighbourhood. They quietly exert their pull, just as any star of equal mass would. Only when an object strays very near does the black hole reveal its true power and inescapable grip. Sometimes, if a black hole has matter around it, gas or dust drawn from a nearby star, it can form a swirling disk of material spiraling into the hole. That disk can become extremely hot and luminous, glowing brightly as it slowly falls inward. We have even managed to capture images of such a phenomenon, a ring of golden light encircling a circular shadow, which is the black hole's silhouette against the glowing disk. It is a striking vision, a radiant halo marking the outline of a void. But our black hole here floats in solitude, with no stream of gas to feast on. In the absence of such material, it remains essentially invisible, bathing in darkness, noticeable only by the way it bends the space around it. No light announces its presence. It is as if an empty void has taken the star's place, a well in space-time that one can fall into, but never see. Drifting alongside this dark remnant, we feel the curvature of space funneling gently toward the black hole. We sense how starlight passing nearby is bent from its path, detouring slightly, as though respectfully circling the black hole's domain. There is a profound stillness here. The black hole does nothing but simply be, an enduring remnant of a long-gone star. It is a well in the fabric of space-time, a deep night that has fallen in on itself. It holds its secrets close, hidden behind the veil of the event horizon, at peace in the darkness. If we could float nearby, we might notice nothing unusual until we looked at the background stars. They would appear strangely displaced, their lights smeared into subtle arcs by the black hole's gravity. All around, however, the emptiness would feel serene. There is no roar or chaos here, only the silent pull of an invisible giant and the gentle distortion of starlight in its vicinity. This black hole will persist for billions upon billions of years. Left undisturbed, it will simply remain, changing only over unimaginably long timescales. In the span of human lives, or even of civilizations, this dark presence might as well be eternal. For all practical purposes, our black hole is here to stay, a nearly permanent fixture of this region of space. Yet it does not sit entirely still. The blast that created it may have given it a gentle push, setting it on a slow journey. It now drifts through the galaxy, a wanderer in the cosmic night. We follow this solitary traveller as it leaves the place of its birth and ventures out into the wider expanse of the Milky Way, alone yet still part of the grand cosmic ballet. In theory, over an unimaginable span of time, a black hole can slowly lose mass and energy through a faint quantum process called Hawking radiation. But for a black hole of this size, that gentle evaporation would take trillions upon trillions of years, far longer than the current age of the universe. To any practical understanding, it will persist, essentially, forever. Our black hole will roam through space for eons to come, a dark point of gravity quietly traversing the galaxy. Through the quiet reaches of the galaxy, our black hole travels onward. It wanders the darkness between the stars, a lone voyager sailing an endless night. The void around it is nearly empty. Occasionally, it passes through a thin cloud of interstellar dust, stirring the material ever so slightly with its gravity. But often, it glides through pure emptiness. It is a solitary existence. There are no nearby stars now to illuminate the black hole's presence, no companions to keep it company. Only the gentle pull it exerts on space, and the subtle effect it has on anything that strays near, hint at its passage. In the grand, dark sea of the galaxy, it drifts calmly, unseen and undisturbed. Our black hole is bound by the gravity of the Milky Way, carried along in the galaxy's vast rotation. It circles around the distant galactic center, alongside uncounted stars, participating silently in the immense sweep of our spiral galaxy. At the core of the Milky Way, a supermassive black hole, millions of times the mass of the Sun, anchors a dense swarm of stars. But our small traveller keeps to the galaxy's quieter outskirts, gliding almost unnoticed through the sparse outer regions. Occasionally, the black hole may wander through a diffuse cloud of gas or dust drifting between the stars. In those rare moments, it finally has something to interact with. Drawn by the black hole's gravity, the stray material will swirl into a spiral, heating up as it falls inward. For a short while, this infalling gas can form a faint, ghostly glow around the otherwise invisible void. The black hole dons a subtle halo of light, shining softly as it quietly consumes the cosmic cloud. But such an event is fleeting. Once the cloud has dispersed into the black hole, the glow fades away. The darkness closes in again, and the black hole returns to its silent, unseen journey. As the black hole continues its journey, it moves at a steady pace. It might be hurtling along at tens of thousands of miles per hour, yet in the vast scale of space, that speed feels like a slow drift. Years pass, then centuries, millennia, and even millions of years slip by as it crosses the immense gulf between stars. Every so often, it ventures closer to a star than usual. When it does, its gravity can tug imperceptibly on the star, like a gentle greeting in the dark. The star might wobble just a little, or gain a tiny extra motion, perhaps a distant planet in its system, shifting subtly in its orbit. Such effects are so slight and gradual that the star and its companions likely never even notice the silent visitor that passed in the night. More often, our black hole slips quietly by, the star unaware that anything unusual has come and gone. In the deep silence of space, even light itself whispers around the black hole. On the rare occasions when the black hole aligns with a distant star far behind it, something subtle occurs. The star's light bends around the invisible mass as it passes almost directly in front. To an observer far away, the star might momentarily shine a bit brighter or shift in position as the black hole's gravity focuses its light, a fleeting trick of gravity and optics that magnifies the star's gleam. It's a phenomenon we call gravitational lensing, and out here it happens without any fanfare. For a short while, the presence of the otherwise invisible wanderer is revealed by this gentle funhouse mirror effect on starlight. Then the alignment passes, and the star's light returns to normal. The black hole slips back into obscurity, once again undetectable. Such is the only sign of this traveller's passage, a brief, subtle bending of light, like a whisper that something unseen has moved across the sky. Drifting through one star field after another, the black hole remains solitary. It is one of perhaps tens of millions of such black holes roaming our Milky Way galaxy. Most of the time, they pass everything by as if ghosts moving in the night, present, but seldom interacting. Space is so vast, and even though black holes are numerous, direct encounters are exceedingly rare. The galaxy is vast, and these wanderers rarely reveal themselves. Millions of black holes may roam the Milky Way, and almost all remain invisible, like phantoms scattered in the dark. They drift unnoticed through the galactic sea, crossing paths with stars only on the rarest of occasions. Our lone black hole is just one of many, yet each moves to its own quiet tune through the stellar wilderness. But the story of a black hole does not necessarily end in eternal solitude. In the expansive dance of the galaxy, paths can cross in time. Gravity is the great matchmaker of the cosmos, and given enough time, even the loneliest objects can be drawn together. Imagine another black hole, perhaps once also a star that died in a brilliant flash, wandering through the darkness on its own long journey. For ages, each black hole travels separately, unaware of the other. But slowly, inexorably, fate can draw them toward a common destiny. The chances are remote, and the process is glacially slow, but the universe has time enough and wonders to spare. One day, our solitary wanderer might drift into the faint gravitational influence of another of its kind. Across light years, they begin to sense each other's presence, like two distant dancers hearing the same faint melody. At first, the pull is almost imperceptible. The two black holes continue on their courses, but now their paths start to curve gently toward one another. Over countless millennia, they draw closer. What was a barely noticeable tug becomes a firm attraction. Eventually, the two black holes become bound in a lonely orbit around each other. They have found a companion in the void. In the silent darkness, they begin to circle, slowly, like partners in a celestial waltz. Round and round they go, in ever-tightening loops. Their dance is quiet. No light marks their movements, only the graceful spirals traced by their immense gravity. As they orbit, they stir the fabric of space itself, sending gentle ripples outward that carry news of their union across the cosmos. Eons pass as the black holes spiral closer, their dance gradually quickening. They are like two whirlpools in a vast, dark ocean, drawing nearer, spinning faster as they come. Eventually, in a moment that is both violent and wondrous, they will meet and merge into one. When they do, a new, larger black hole will form, and a tremendous surge of energy will ripple out into the universe. Through it all, they remain shrouded in darkness, emitting no light. Only the vibrations of spacetime itself signal their presence when the finale comes. In that final fraction of a second, when they collide, they unleash energy beyond imagining, though it radiates out not as light, but as ripples in the very fabric of space. The universe briefly rings with the force of their final embrace, then gradually falls quiet again as the new, larger black hole settles into silence. The very fabric of space-time will quiver from the force of their merger. These ripples, gravitational waves, will wash across galaxies, faint and fleeting by the time they reach distant worlds, but unmistakable to those who are listening. It is the grand crescendo of the black hole's dance, a moment of cosmic transformation born from their lonely journey. For now, however, that destiny lies far in the future. Our black hole continues its solitary voyage through starlight and darkness. The prospect of a companion, of a cosmic dance, remains only a possibility on the distant horizon of time. In this moment, beneath the quiet stars, the black hole drifts peacefully, enfolded in the endless night. The universe around it is silent and still. Yet somewhere ahead, perhaps tens of millions of years from now, the first notes of that future encounter are waiting to play. The black hole's journey is not over. It is simply flowing onward through the cosmic night until the time is right for its dance to begin. And so, in the tranquil darkness, we leave our solitary traveller for now, gliding through the endless void, patiently awaiting the unknown dawn of its next chapter. For now, all remains calm. Under the silent canopy of stars, the cosmos holds its breath, keeping the secrets of tomorrow quietly tucked away until the moment is right for them to emerge. In a lonely corner of the cosmos, where starlight is scarce, two invisible wanderers drift alone. Each is a black hole, a dense remnant of a long-dead star, carrying the weight of countless suns in a point of infinite darkness. They roam through the silent void, solitary and unobserved, moving as they have for eons in isolation. Not even a stray particle of dust crosses their path. Nothing external interacts with them in this void. They slip through space completely unseen, detectable only by the gravity they wield. For now, they remain oblivious to one another. One drifts in one corner of this darkness, a silent well of gravity moving without aim. Far across the void, the other wanders on its own lonely path. Each is like a solitary figure on a vast stage, each the centre of its own silent gravity. They are so far apart that, for eons, neither has felt even a whisper of the other's presence. In the vast void between galaxies, such a meeting seems nearly impossible. Like two grains of sand drifting in a boundless cosmic ocean, somehow finding each other. Yet the universe is old and patient, and even the unlikeliest paths can intersect given enough time. And now, in this silent expanse, a quiet chance is unfolding. For countless ages, each black hole journeyed alone, unaware of the other. Now, by a gentle twist of fate, their paths begin to converge. Across the lightless gulf, a faint influence passes between them. It is the first hint of companionship either has ever known, as if two lonely souls have whispered a greeting to one another across an ocean of night. Each feels that subtle tug from the other, a delicate pull, signalling through the dark. It is almost imperceptible, but it is enough. Slowly, inexorably, they drift toward one another, drawn by an invisible thread of gravity. Time flows on, unhurried in this quiet quarter of the universe. For a long while, nothing seems to change as the two black holes inch ever so gradually closer. There is no rush in the void. Their approach is almost imperceptibly slow by any human measure. Years and centuries slip by in silence as each drifts steadily toward the other. In the darkness, there is no sense of scale or motion, only the subtle tightening of the distance between them. What began as a faint gravitational whisper now grows into a soft murmur, an unspoken promise that the two will meet. Little by little, the pull strengthens, guiding them along a path that draws them inevitably together. At last, they no longer drift freely. The quiet force between them has claimed both, pulling them into a mutual orbit. There will be no chance glancing past in the night. These two travellers are firmly caught in each other's gravity. Gradually, inexorably, they begin to circle a common centre, bound now in a shared fate. In the darkness, the two black holes now move as one system, bound by their mutual pull. They have entered a slow, graceful orbit, circling each other in a silent cosmic dance. No longer alone, each one now has a companion in the void. They revolve around an invisible point between them, an unseen pivot in the emptiness, tracing out a broad circle in the endless night. It is an orbital embrace, a gentle dance that carries on in perfect silence. In this cosmic union, two once isolated wanderers have finally found each other. Round and round they go, in a steady rhythm dictated by gravity alone. From afar, their movement would resemble that of twin stars locked in orbit. But these are no stars at all. They cast no light, no warmth. Instead, two invisible masses whirl in darkness, their presence betrayed only by the gravity that tugs on space around them. If a stray beam of starlight passed through this region, it would bend and curve around the unseen dancers, momentarily forming a faint halo before slipping back into darkness. But here, in this lonely void, even starlight seldom intrudes. For now, their dance remains truly secret, hidden in the dark. In this remote expanse, they have only each other. No nearby suns, no orbiting worlds, nothing external to disturb their private dance. Time loses its meaning here. All that matters is the continual motion of two partners moving in synchrony. Each orbit might take years, yet neither ever tires, and the pattern repeats endlessly. They remain locked together, two dark dancers against a backdrop of eternal night, their union calm and enduring. Beyond this isolated dance, the cosmos carries on its bustling life. Elsewhere, stars are born in radiant bursts of light, and others die in spectacular supernovae. Galaxies collide and merge, solar systems form and dissolve. But in this remote darkness, none of that stir penetrates. Here there are no bright flares or cosmic dramas visible, only the quiet inevitability of two black holes drawing ever closer. Beneath the grace of their movement lies a delicate balance of forces. Each black hole is drawn toward the other by gravity, yet each also carries enough sideways momentum to avoid a direct plunge. In essence, they are perpetually falling toward one another, but their motion causes them to continuously miss, swinging around instead of colliding. This is the nature of orbit, a continuous fall that never finds an end. It's the same principle that keeps planets circling their stars, gravity pulling in, momentum carrying forward, resulting in a stable path. Thus, these two dark giants glide around each other, held together by gravity's embrace, even as their motion keeps them apart for now. For long stretches of time, nothing seems to change. Orbit after orbit, the black holes continue their stately waltz, each loop much like the one before. It almost appears eternal, an endless night of two companions circling in serene unison. One could imagine this quiet dance carrying on forever, unaltered and everlasting. Yet even this steady dance is slowly changing. With every revolution, the two black holes drift a little closer together, their bond tightening by an almost undetectable degree. Nothing external pulls on them, and still, a subtle energy slips away into the cosmos each time they circle. It is as if the very fabric of space is gently carrying off a piece of their dance. In response, their orbit contracts ever so slightly. Their gentle waltz becomes imperceptibly quicker, the partners drawing nearer with each passing century. What seems constant is in fact evolving, setting the stage for a deeper embrace in the ages to come. Gravity, patient and unyielding, continues to guide them, pulling them ever closer. Ages slip past in the cosmic night, and the two black holes continue their endless ballet. Slowly, almost imperceptibly, their dance has changed. They orbit closer now than they did in ages past, their path tightening as time flows on. What was once a broad, leisurely circuit has narrowed into a smaller loop. Their dark forms now swing around each other a bit faster, drawn ever inward by their mutual gravity's steady pull. With each tightening orbit, a new phenomenon emerges from their dance. The fabric of space-time, stretched and warped by their motion, now begins to ripple outward. Each time the black holes circle, they send faint vibrations through the very structure of the cosmos. These are gravitational waves, gentle murmurs in space and time itself, emanating from the whirling pair. They spread out like ripples on a dark, still pond, expanding ever outward from the black hole's orbit. At first, these ripples are incredibly subtle, mere whispers in the silence of space. Yet they carry away energy from the dance. Each wave steals a tiny bit of the orbital energy and carries it off into the void, like a soft sigh that gradually draws the dancers closer together. For so long, their dance was completely hidden, without a trace of light or sound. Now, at last, something escapes this dark duet. Not light, but a gentle signal in the fabric of space. Through these gravitational waves, the silent dance announces itself to the universe. Though incredibly faint, these ripples are the only messengers of the black hole's movement, carrying news of their spiraling embrace out into the cosmos. No eyes can see them, and no ears can truly hear them. Yet the universe subtly feels their presence in these quiet gravitational whispers. Silently, those gravitational ripples race into the depths of space. They propagate outward at the speed of light, spreading through the cosmos like expanding circles on a pond. Unlike light or sound, they pass unhindered through everything in their path. They stretch and squeeze the space within galaxies, brushing past stars and planets without a sound or a flash. By the time these waves reach faraway realms, they are vanishingly faint, yet they continue on, carrying the story of this black hole dance across the universe. As time marches on, the effect feeds on itself. Drawn closer by each lost bit of energy, the black holes begin to circle each other ever faster. And as they move faster, the ripples in space-time grow a touch more pronounced. What started as a barely perceptible whisper now builds toward a gentle hum. The gravitational waves arrive in a quicker cadence, a soft cosmic rhythm that is slowly gaining tempo. It is like a distant lullaby that is gradually speeding up, still quiet and soothing, but hinting at a coming crescendo. The once leisurely waltz has become a more urgent dance, though it remains graceful and silent to the cosmos watching from afar. Orbit by orbit, the distance between the black holes dwindles. What began as a distant gravitational courtship has become a close embrace. The two shadows now sweep around each other at a fraction of their original separation, and with each passing moment that gap continues to close. Their dance, once languid, is now markedly faster, a prelude building toward a grand cosmic event. All the while, space-time quietly sings with their motion, a gentle premonition of the climax to come. The stage is slowly being set for the final act of this celestial ballet, as the black holes move inexorably toward an ultimate union. The two black holes are now locked in an astonishingly tight orbit. What once took millennia upon millennia now happens in the blink of an eye. They whip around each other with breathtaking speed, circling nearly at the speed of light and completing orbit after orbit in mere moments. From having been separated by light years, they are now divided by only a tiny span of space, so close that their dark edges nearly touch. In this final dance, they whirl around a common center at a rate that defies imagination, yet in the vacuum of space, their furious motion remains eerily graceful and silent. Space-time itself is now being dramatically churned by their rapid motion. The gentle ripples that once radiated from their dance have amplified into sweeping waves cascading outward. What was a soft whisper has grown into a steady, resonant hum reverberating through the cosmic fabric. With each fraction of a second, a new surge of gravitational energy races away, carrying with it the story of this impending union. The very fabric of the universe is ringing with their movement, like a great cosmic bell that tolls in frequencies no ear can hear. And still, amid this tremendous outpouring of energy, the scene remains one of silent darkness. No flash or sound accompanies the drama, only the ceaseless tremor of space, announcing that the end of the dance is near. At this extreme proximity, even the black holes themselves begin to feel each other's influence in unprecedented ways. Their immense gravities distort one another. Each black hole's event horizon, the shroud of darkness surrounding it, stretches and bulges toward the other. It is as if their very edges are yearning to meet. The space between them has become a tempest of gravity, a rapidly shrinking funnel through which both bodies are being inexorably drawn. The leading edges of their darkness nearly brush past one another with every orbit, the distinction between the two beginning to blur. Only a sliver of space remains between them now. In these final circuits, the black holes almost share a common envelope of warped space, held apart by the last tiny gap that has yet to close. Now the black holes are on the very brink of merging. They have run out of space to spiral. Their next movement will bring contact. In these final instants, their motion, which had been so rapid, seems almost to pause in a silent anticipation. It is as if the entire universe holds its breath, waiting for the inevitable. The two silhouettes are almost one, their event horizons so close that they nearly overlap. Every ounce of gravitational force pulls them together now. There is nothing left to keep them apart. All the energy and momentum of their long dance is focused into this single, breathtaking moment. For all the unimaginable power concentrated here, a profound serenity pervades the moment. Everything unfolds in silence, as though the universe itself is reverently watching this final embrace. No fanfare accompanies it, only the steady pull of gravity and the certainty that a profound transformation is about to occur. It is the end of their lonely journey and the beginning of something new. At the edge of collision, the gravitational song reaches its crescendo. Those once faint whispers have become a rapid, high-frequency thrumming coursing through space-time. In this final heartbeat of their dance, the cosmic hum rises to its highest pitch and intensity. Space-time itself quivers with the strain of two massive bodies on the verge of becoming one. It is the last, powerful stanza of their gravitational melody, a final announcement echoing across the darkness that the moment of union is at hand. In that final instant, the energy released is almost unimaginable. For a brief moment, their merger will outshine entire galaxies in gravitational waves, all without a single spark of light. Closer and closer they come, as if time itself has slowed to watch. The final sliver of separation dwindles to almost nothing. In the next heartbeat of the universe, these two black holes will finally become one. In the silence of the cosmic night, countless stars shimmer gently in the distance. Their light is faint and steady, a quiet glitter across the black velvet of space. The universe feels serene and boundless, a vast expanse of darkness sprinkled with the soft glow of galaxies. Far from any noise or disturbance, this infinite night carries a deep peace. It is a stillness so profound that one can almost feel the gentle breath of the cosmos itself. High above, a pale river of starlight marks the heart of our galaxy. This is the Milky Way seen from within, a faint band where uncountable stars mingle their light. Dark lanes of dust weave through that band, and here and there a delicate nebula glows with a gentle pastel hue, the birthplace or graveyard of stars. The universe appears calm and unchanging on this grand scale. In the foreground, a lonely comet might drift past, its icy surface reflecting a distant sun's light faintly, like a traveller passing under far-off street lamps. All these sights are part of the still tableau of the cosmos at rest. Among the shining stars and soft nebular glows, there are patches of pure darkness, places where no star shines at all. In these voids might lurk a black hole, a silent guardian of the night, invisible to our eyes. We cannot see a black hole directly, but the universe offers gentle hints of its presence. A lone star may circle an unseen companion and wobble in its path, tugged by a gravity with no visible source. Or a beam of light from a far-off star might bend into a strange halo, warped by an invisible mass in its way. These subtle signals whisper that something powerful is hiding in the dark. Only by such quiet clues, a star's dance or a bent ray of light, do we know that a hidden dancer moves in the cosmic night. Imagine floating in this tranquil abyss, where starlight is scarce and time seems to slow. In the distance, a cluster of stars glimmers like a tiny jewel. But here, away from that gentle light, you are enveloped by calm darkness. No wind blows in this vacuum. No sound can travel through the emptiness. Your only companions are faint twinkles far away and the profound hush of space itself. You feel no up or down, just the gentle cradle of emptiness in all directions. The nearest stars are so far that their light offers no warmth, only a distant, friendly twinkle. Instead of loneliness, a calm reassurance surrounds you, as if you are an accepted part of this endless night. In this silence, even your thoughts seem to slow, syncing with the unhurried rhythm of the cosmos. Without a single ray of light, a black hole drifts nearby, silent and unassuming. It does not announce itself with a glow or a flare. Instead, it simply exists, a pocket of intense gravity wrapped in darkness. Around it, space itself is curved and calm, as if bowing to the presence of something immensely heavy, yet perfectly concealed. If you were close enough, you might feel its subtle influence, a delicate gravitational tug, like a slow current in an otherwise still ocean. This is the realm of black holes in the cosmic nightfall, a place where darkness gathers and gravity reigns supreme. In this tranquil setting, black holes dance a quiet dance with the stars around them. They pass through the sea of night, almost like ghosts, felt but not seen. And as we begin our journey through this peaceful cosmic ocean, we keep our eyes on those invisible movements in the dark. Something quietly wondrous is happening in the shadows of the universe, and it is here that our story unfolds. Not all darkness in space is empty. For some darkness comes from these mysterious objects born from the death of stars. Scattered across the galaxy, they quietly mark where brilliant suns once shone. Each black hole is like a silent echo of a star that has lived its life and faded away, leaving only gravity behind. In this way, the darkness itself tells a story, if one knows how to listen. It speaks of stars that died in great cosmic events, and of the quiet that followed those storms. The cosmic night is ancient and patient. Stars are born. They blaze with light for millions or billions of years, and eventually, even the greatest of them grow old. When a giant star reaches the end of its shining life, the darkness welcomes a new black hole into its fold. Out of brightness comes shadow. Out of a star's final fury comes a calm, dark center. These newborn black holes settle into the silent tapestry of the universe, almost as if they were always there. And so, amid the tranquil darkness, changes are always happening in slow motion. A distant star exhausts its life and winks out. A black hole quietly takes its place. The vast night absorbs the change without a sound. From afar, nothing seems different. The night remains as peaceful and deep as before. But hidden in that darkness is something new. A compact, heavy remnant, gently tugging at anything that drifts near. A new dancer stepping into the cosmic ballroom. As we drift further into this story, imagine focusing on one faint region of the sky, where a drama is about to unfold in the most gentle of ways. In the grand stillness, one particular star's light is trembling on the verge of darkness. The serene cosmos is poised to witness a transformation, the end of a star and the beginning of a black hole. In the next quiet act of our journey, we will watch a star's final farewell and see how a black hole is born from its last glowing embers. There is one particular star in a quiet corner of the galaxy that has been shining for millions of years. It is a giant, many times more massive than a typical star, and for ages it has burned with a brilliant light. Once blue-white and fierce, it has now grown old and large, swelling into a reddish glow as it nears the end of its life. This star has lived a long, luminous life, but even stars must eventually face their final dusk. It has even begun to pulsate softly, each subtle expansion casting off a thin shell of its outer gas into space. In a sense, the star is already beginning to shed its outer layers, as if preparing for its final act. Deep inside the star, the fire that has fueled it is running low. The core has fused element after element, growing hotter and denser with time, until it can fuse no more. In that quiet center, the balance that held the star steady begins to falter. There is less outward pressure from burning fuel, and the immense weight of the star starts to press inward relentlessly. In the star's last moments, its core can no longer bear the crushing load. Suddenly, the core collapses in on itself in a fraction of a second. The collapse is so intense that it's as if the heart of the star vanishes into a tiny point. This dramatic implosion sends a shockwave racing outward through the star's layers. In an instant, the star's outer shell is blown outward in all directions. What was once a calm, glowing giant erupts into a supernova, one of the universe's most awe-inspiring fireworks. From across the darkness, this event appears as a sudden bloom of light. For a brief time, the star outshines all the others around it, lighting up its region of space like a cosmic lantern. Gases and stellar material burst outward, forming expanding clouds that shimmer with brilliant radiance. They glow with hues of soft pink and violet against the darkness, like colourful ribbons unfurling. The explosion unfolds in perfect silence, for in space there is no air to carry sound. To any distant observers, it is a spectacular yet soundless light show, a star's final silent crescendo. The debris of the star, glowing hot plasma and gas, billows outward in a beautiful, ever-expanding nebula. Bright tendrils of what was once the star's substance spread into space like colourful ribbons unfurling. Over weeks and months, that shell of debris will cool and fade, its vibrant colours softening as it stretches further into space. What remains of the star's outburst gradually blends back into the starry background, a delicate haze where a furious inferno had been. And what of the heart of the star that collapsed? In those fleeting moments during the supernova's birth, the core of the star was crushed beyond anything we can truly fathom. All the remaining mass of the star's centre fell into itself, becoming smaller and denser until it formed something entirely new. In the aftermath of the explosion, when the dust and light begin to clear, a strange, dark object remains where the core once was. This is the birth of a black hole. Where once there was a blazing star's heart, there is now a region of complete darkness. The core has become so dense that it punched a hole in the fabric of space itself. An object with gravity so strong that nothing, not even light, can escape its grasp. At the moment of its formation, the black hole is like an infant in the cosmic night, born from violence but instantly cloaked in quiet. The supernova's fury dies away, and a calm falls over that region of space again. The expanding nebula continues its slow spread, but at the center, in place of the star, hovers an invisible new presence. The newborn black hole is utterly dark. If you were nearby, you would not see the black hole itself, only the absence of light where it sits. It's as if a piece of the night sky has taken on a life of its own, a patch of darkness with gravity's immense power concentrated inside. For a moment, remnants of the explosion may swirl around the black hole. Some of the ejected gas might fall back, spiraling inward, and as it does, it could briefly form a disk of hot material, glowing as it vanishes from our universe. But soon, even that light will fade. The remaining gas drifts away to join the nebula, leaving the black hole in solitude. After the brilliant flash of the supernova, all is once again still and dark. In this gentle aftermath, the black hole simply remains. It neither shines nor explodes. It is a silent witness now, a heavy, invisible thing where a star's heart used to beat. The space around it is calm, as though the universe itself is taking a deep breath after the drama. The black hole settles into its new existence, hidden in plain sight. What was born in fire and light has now become perfect darkness. And so, in the quiet following a star's end, a black hole's life begins. For a fleeting moment, this dying star poured out more light than perhaps billions of ordinary suns combined. The supernova became a beacon in the galaxy, a brilliant flash that could be seen across vast distances. But this brilliance, as intense as it was, lasted only briefly. Over the next days and weeks, the light began to dim. The once blazing debris cloud cooled and faded, its vibrant colours softening as it stretched further into space. What remained of the star's outburst gradually blended back into the starry background, a delicate ghost of the star's former glory drifting among the stars. When the last traces of the explosion's glow finally diminished, tranquility returned fully to this corner of the cosmos. All that was left of the great star was a faint memory painted in scattered gas, and at the centre, an enduring mystery. The black hole now drifted where the heart of the star had collapsed. It was so small compared to the giant star that birthed it, and yet so massive. An object, perhaps only a few tens of kilometers across, now held the bulk of a star's mass, hidden behind a veil of darkness. It was an uncanny transformation. The star that once shone across light years was now condensed into an invisible pinprick of intense gravity. Yet nothing about this scene feels violent now. The violence is over. What remains is quiet. The newborn black hole doesn't radiate fury or chaos. Instead, it sits in the center of the expanding nebula, like a calm, dark eye in a fading storm. Gravity gently draws in some of the closest matter, but most of the star's former substance is traveling outward, beyond the black hole's reach. The black hole simply takes its place as a new inhabitant of the cosmic night. This gentle ending belies the tremendous forces that created the black hole. Out of the star's destruction has come a profound stillness. Space around the object has settled, and starlight from afar continues to pass through this region, unaware that anything has changed. Only if a beam of light strays too near will it find the path altered, bent, or pulled in by the dark presence now at the star's grave. For now, the black hole remains a silent sentinel, marking the spot where a brilliant star lived and died. In the grand story of the universe, a new chapter has quietly begun. The remnants of the exploded star will not be idle in the eons to come. The gas and dust hurled into space will gradually mix with the interstellar clouds of the galaxy. In time, those materials, rich with elements forged in the star's heart, may become the seeds for new stars and new planets. Thus, even as one star's light has faded, it leaves behind the building blocks for future worlds. In this quiet way, the cycle of stellar life continues. And at the center of it all, the newborn black hole remains, a silent keeper of the star's last chapter, while the galaxy moves forward with the legacy of that star spread among the cosmos. Now we draw closer to that newborn black hole, to examine its nature, the very heart of darkness it carries. From a distance, a black hole doesn't look like much at all, just a patch of emptiness. But as we imagine moving nearer, the true character of this mysterious object begins to reveal itself. The black hole is not a solid sphere like a planet or a star. Instead, it is an almost ethereal region of space, defined by an invisible boundary. This boundary is often called the event horizon, a fitting name, because it is the horizon beyond which no events can ever be seen by the outside universe. Picture the event horizon as an imaginary sphere surrounding the black hole's center. If anything, a particle, a beam of light, or even a spacecraft passes through that boundary, it will never return. That is the point of no return, the one-way door into the black hole's depths. From outside, you could hover just at the edge of this boundary and still escape if you left quickly enough. But cross that line, even by an inch, and the escape velocity becomes greater than the speed of light itself. There is no turning back. The black hole's gravity will draw you inexorably inward, deeper into the darkness. This invisible surface has no texture or color. It's not a tangible wall, just the threshold where gravity's pull becomes overwhelming. The space just outside the event horizon may appear deceptively normal and calm. If you were watching from a safe distance, you might not notice anything unusual at first glance, until you saw how anything that strays too near begins to vanish. It's as if the universe has a hidden trapdoor here, silently swallowing matter and light. The gravity of the black hole is immense. It curves space around it like a bowling ball on a soft mattress. Except here, the ball punches a hole straight down. Imagine space as a calm, stretched-out fabric. The black hole is like a deep well or a funnel in that fabric. Objects that come near find themselves sliding towards the center, drawn by a force that grows stronger with proximity. Even beams of starlight passing close by have their paths bent and twisted. In some cases, a passing light ray will loop around the black hole, allowing us to briefly see what lies behind it, distorted and doubled. These are gravitational mirages, subtle hints that something powerful resides in the dark. Closer to the black hole, time itself begins to stretch and slow relative to far away. If an observer could watch a clock falling toward the event horizon, they would see that clock tick more and more slowly. By the time it neared the boundary, the clock would appear almost frozen, its last moments of time drawn out into eternity from an outside perspective. The falling object would dim and fade, never quite seen to slip inside. In reality, of course, it does cross over, continuing its descent unseen. But to the outside universe, that final approach appears to take forever. Such is the strange nature of space and time around a black hole. And what lies inside, at the very center of this gravitational abyss? This is where the true mystery begins. All the mass that once was a star, and anything else the black hole may have consumed, is now compressed into an unimaginably small volume. We call this the singularity, a single point deep in the black hole's core where density becomes infinite in theory. No one really knows what the singularity is like, or if it's even a pinpoint or something else entirely. Our laws of physics as we know them cease to give clear answers in this realm of extremes. It's a strange concept. A whole star's worth of mass, perhaps millions of trillions of tons, crushed down to something smaller than a pebble, hidden behind the curtain of the event horizon. The singularity is the heart of the black hole's darkness, but it's a heart we can never see or touch. It is perfectly concealed, wrapped in the ultimate secrecy by the black hole's gravity. In a way, one could imagine that inside the event horizon is a kind of stillness or endpoint, a place where time and space, as we understand them, come to an end. We don't know if anything moves at the singularity or if it's frozen in time. It is, for now, a profound and silent mystery. From outside, all we notice is that nothing returns once it passes the horizon. The black hole gives away nothing about its inner secrets. It's as if the black hole swallows not just objects, but their stories as well. No information escapes to tell the tale of what happened inside. In this sense, the black hole's interior is a region of complete silence and darkness, truly a heart of darkness in the literal and figurative sense. Yet, the presence of a black hole can be felt. While it hides everything that falls in, its gravity still reaches out beyond the event horizon. A black hole can tug on nearby stars, or collect a disk of gas swirling into it, which heats up and shines before crossing the horizon. It can even slingshot comets or asteroids that wander too close, flinging them away with changed paths. These effects on its surroundings are like the black hole's indirect voice, hinting at its existence. But if left alone in a quiet region of space, a black hole simply drifts in perfect darkness, practically indistinguishable from the void, except to those who know how to look. So here we have this paradoxical object, extremely powerful, yet outwardly so quiet, immensely heavy, yet seemingly empty, a destroyer of matter, yet also a creator of mysteries. The black hole we've followed, born from a star's death, is now such a silent enigma. In its center lies the unknown, and around it lies the gently curving space of its gravity well. It is perfectly at home in the darkness, a calm and unilluminated presence that simply is. The heart of darkness is not chaotic to our eyes. It is pure tranquility, a deep and abiding stillness that holds within it the greatest of cosmic mysteries. Contemplating this black hole, one feels a sense of reverence and wonder. It reminds us that there are places in the universe our eyes will never see, and truths we cannot yet uncover. And yet, even in their secrecy, black holes are a fundamental part of the cosmic dance. They have their role to play and their story to add to the universe's grand tale. In the next part of that story, we will leave the still solitude of a single black hole's heart and witness what happens when one of these quiet wanderers encounters another in the vast night. But for now, for a moment, we simply sit in the calm gravity of this black hole's presence, appreciating the quiet power and mystery that it embodies. Time flows onward, and the scene of the star's death grows tranquil and distant. The brilliant nebula left behind by the supernova expands and fades into the background of space. Decades pass into centuries, centuries into millennia, and the glowing remnants of the explosion become thin and dim, eventually dispersing among the interstellar medium. What remains at the center is our black hole, solitary and almost indistinguishable from the void around it. It has no light of its own, and now no surrounding gas to make it glow. In this quiet aftermath, the black hole begins its long journey through the galaxy, a lone wanderer born from a vanished star. The black hole glides silently through space. In truth, it is moving. Perhaps the supernova's blast gave it a gentle kick, setting it on a slow drift away from its birthplace. Or maybe it simply continues along the orbital path the star once had around the center of the galaxy. Either way, the black hole's motion is steady and unhurried. To an outside observer, it's as if a small patch of darkness is wandering across the starry backdrop. There is no rush in its travel. It carries the same measured pace as the stars around it, orbiting the galactic core over millions of years. All around, the galaxy is alive with stars, but the black hole's immediate vicinity is mostly empty. It passes through vast regions of sparse gas and dust, essentially invisible. Occasionally, it might stray near a cloud of gas or a cluster of stars. When it does, its gravity subtly perturbs the cosmic dust or nudges the path of a wayward comet, but these encounters are gentle and rare. Most of the time, the black hole drifts in solitude, like a ship sailing through a boundless, dark ocean with no land in sight. It's a majestic loneliness. The black hole is utterly quiet, yet it commands respect in its silence. If a star happened to wander too close, the black hole could snare it, drawing material off the star and creating a brief, luminous halo of X-ray light. But in this remote part of space, such meetings are extraordinarily uncommon. Instead, the black hole remains a dark, ghostly traveller. It's there, but only gravity knows it. To our eyes, it's as if nothing is there at all. On rare occasions, the black hole may wander through a sparse cloud of gas. As the cloud's wisps draw near, the black hole's gravity pulls a small stream of material inward. The gas forms a fleeting, whirling disk as it spirals toward the dark center. Friction in the disk heats the gas until it glows softly in X-rays, giving the black hole a faint halo of light. For that short period, the black hole is not entirely invisible. It wears a subtle, ghostly radiance in the darkness. An observer far away might notice a gentle flare of energy from an otherwise empty patch of sky, a quiet sign that something was momentarily there. But the meal is scant and soon over. Once the thin stream of gas has been swallowed or scattered, the glow fades away. The black hole returns to its deep silence, as unassuming as before, with no hint that it briefly dined on starlight's raw ingredients. Imagine, for a moment, we could follow along beside this black hole on its journey. We would see the distant stars slowly changing position over millennia as the black hole moves. We might notice an occasional flicker of starlight bending if the black hole passes almost directly in front of a distant star, a subtle wink as the black hole's gravity focuses the star's light for a moment. These would be rare hints of the wanderer's presence, brief moments where the black hole announces itself before slipping back into obscurity. Through the eons, the black hole continues its solitary voyage. It has no companions, no light, no sound, just the tapestry of stars slowly swirling around the galaxy with it. One could think of it as lonely, but it's a loneliness born not of sorrow, rather of nature. The black hole simply is, content in the emptiness, an island of extreme gravity moving in the sea of night. Yet, the universe is vast and full of possibilities. Just because the black hole is alone now does not mean it will be alone forever. In the grand dance of the galaxy, paths can cross when given enough time. Perhaps far in the future, this wandering black hole will come into the vicinity of another remnant of a dead star, another black hole roaming in darkness. Gradually, almost imperceptibly at first, they might begin to feel each other's presence, drawn together by the very gravity that makes them what they are. Unbeknownst to our lone traveller, far across the darkness, there is indeed another such wanderer. They are separated by vast distances, each tracing its own route through the galaxy. Yet, very slowly, destiny, in the form of gravity, is drawing them onto a converging course. At first, it's an almost imperceptible drift, a tiny gravitational tug felt over light years, a gentle beckoning through the void. It may take ages upon ages, but gradually, the distance between these two black holes is closing. Neither is aware, of course, but we, as observers of this cosmic story, can foresee that their solitude will not last forever. One day, the silent traveller we have been following will no longer be alone. It will have a partner in the darkness, and the two will begin a new journey together. For now, this is only a hint of what the future holds, a faint overture to a much grander movement of the cosmic symphony. The black hole continues its solitary flight a while longer, carrying the silence of its origins with it. But out in the darkness, the stage is quietly being set. Two lonely paths are on their way to crossing, and when they do, even the deep tranquility of space will be stirred by their union. With this anticipation hanging gently in the star-speckled night, we drift with our black hole toward the threshold of the next chapter of its existence, the moment when it will encounter its long-awaited companion. In the depths of space, the two black holes drift ever closer, drawn together by their mutual gravity across the silent darkness. At first, their approach is almost imperceptible, a slow convergence that takes eons. They are like two lone wanderers, finally coming within each other's influence after ages of solitude. From light years apart, they begin to sense each other's presence, a delicate gravitational tug, growing stronger as the distance between them shrinks. In this vast emptiness, an invisible thread is tightening, pulling these dark travelers into a shared path. Gradually, what was once a straight journey for each black hole bends into a curve. Instead of continuing on separate ways, they begin to orbit around a common center, bound by gravity's unbreakable tie. The orbit at first is enormous and leisurely. The two black holes circle one another at a great distance, perhaps with many trillions of kilometers separating them. One orbit might take thousands of years to complete. In these early stages, their motion together is a stately waltz, almost indistinguishable from the steady drift they once knew alone. Nothing sudden or jarring announces this change, only the quiet fact that now neither black hole is truly solitary. As the black holes begin their slow dance, the surrounding stars continue to shine calmly, unaware of the rendezvous unfolding in the darkness. There is no light to mark the occasion. The black holes remain perfectly dark, and even from nearby there would be almost no sign that two massive objects are swirling around one another. But if one could map the invisible forces at play, one would see a beautiful pattern emerging. Two gravitational fields entwining, two heavy masses circling in a duet. Imagine observing this from a great distance. You wouldn't see the black holes themselves, but you might notice the effect on any stray material in the vicinity. Perhaps a thin cloud of interstellar gas is drifting far off. As the black holes move together, their combined gravity can tug on that gas ever so slightly, causing subtle currents. If there were a cluster of stars positioned just so, you might detect the faintest wobble in their motions, influenced by the gravity of this new binary of black holes. These would be minuscule hints, likely too small for all but the most sensitive instruments to catch. To the cosmos at large, the two black holes remain essentially invisible and their union unnoticed. Yet, something profound has changed. In a universe where gravity rules the dance of galaxies and stars, two of the most extreme objects have found each other. What was once a solitary journey for each has become a shared orbit. They are partners now in a gravitational ballet, bound together by forces neither can escape. In the darkness, they silently begin circling, an ancient loneliness slowly giving way to a cosmic companionship. For a very long time, this orbit remains vast and slow. The black holes coast through space, tracing a huge ellipse around their shared center. With each pass, they draw just a little nearer to one another, their bond strengthening. The change is almost unnoticeable at first, like the gradual tightening of a spiral that spans light years. But gravity is patient and persistent. Over countless millennia, the separation between the two black holes decreases. Where once they were separated by a gulf of space, now that gap is closing bit by bit. As the distance shrinks, their dance picks up the faintest hint of speed. They move a touch faster in their orbit than they did a million years before. The difference is slight, but it is the beginning of a long acceleration that will continue inexorably. The two black holes have begun a journey that will end in an embrace, though that finale lies far in the future. For now, they simply keep circling at a respectful distance, two dark partners bound in a slow, elegant dance through the starry quiet. Even at this stage, the dance produces a kind of music, not of sound, but of space-time itself. Each time the black holes orbit, they disturb the fabric of space just a little, sending out tiny ripples. These ripples are gravitational waves, ever so faint in these early days of the orbit. They carry away a whisper of energy from the system, energy stolen from the motion of the black holes. It's as if the dance floor of space-time is responding to their movements, echoing with gentle tremors that spread outwards. These first gravitational waves are unimaginably weak, passing through the universe unnoticed, like a soft sigh in a vast empty hall. Still, those whispers have an effect. With each tiny bit of energy radiated away by gravitational waves, the black holes spiral just a little closer. The difference may take thousands of orbits to amount to anything measurable, but it is inevitable. The two black holes are slowly losing orbital energy, causing their paths to tighten. Their fate is sealed. They are on a slow collision course, guided by the very space-time around them. Through it all, the overwhelming feeling is one of patience and grace. The universe provides all the time needed for this dance to play out. There is no hurry. The black holes, devoid of any will or intent, simply follow the natural laws governing them. They orbit, emit subtle gravitational murmurs, and draw closer, step by step. In the silent darkness, the stage is set, and the dancers are in motion. The lonely nights of wandering are over. Now there is the promise of union, however distant that moment might be. As we leave this scene for now, the two black holes continue their slow circling, two silhouettes in a sea of stars, bound together in the faintest of embraces. Their story is no longer two separate solos, but a duet. In the next chapter of this cosmic tale, ages will pass, and their dance will quicken. What begins here as a barely perceptible motion will grow into a sweeping spiral, drawing them ever inward toward each other. The gentle prelude of their meeting will, in time, give rise to a breathtaking crescendo. But for now, the prelude plays on, softly and calmly, deep in the quiet of space. Time flows on, and the once languid waltz of the two black holes steadily quickens. Millions of years slip by as they spiral ever closer. What was a dance taking millennia for a single step is now speeding up. The black holes that once orbited at a nearly imperceptible crawl have drawn significantly nearer, and their mutual revolution has become swifter. With each passing epoch, their separation lessens and their pace increases, like two dancers gradually picking up the tempo. Their orbit, once measured in light years across, contracts to dimensions far smaller. From a distance that could swallow a solar system, they have come to circle each other, perhaps only as far apart as the outer planets are from a star, then closer still. When their dance had only just begun, an orbit might have taken thousands of years. Now it might take mere hours. The acceleration is inexorable. As the spiral tightens, what was once a gentle turn has evolved into a rapid whirl. Despite the increasing speed, the dance remains smooth and controlled. There is no jolt or sudden burst, just a continuous, graceful increase in tempo. The two black holes trace ever smaller ellipses around their shared center of gravity. In the silence of space, they chase each other in circles, drawing closer with every loop. It's as if they are skating on the fabric of space-time, and as they pull inward, like figure skaters drawing their arms close, they spin ever faster. During this phase, the gravitational whispers they once emitted have grown into a louder chorus, though still far beyond the realm of human hearing. The ripples in space-time, those gravitational waves, strengthen as the black hole's speed increases. Each orbit now sends out a more pronounced ripple, carrying away energy more rapidly. What began as a barely detectable sigh of spacetime has become a gentle hum permeating the cosmos. If we could translate these waves into sound, we would hear a clear tone rising slowly in pitch and volume, a cosmic melody playing out over millions of years. As the black holes whip around each other, they are still invisible in the darkness, yet their influence becomes unmistakable. Any stray gas or dust within light years would feel the effects of their furious gravity dance. Caught between two massive moving objects, matter would be stirred and agitated, perhaps forming spiral patterns of its own in response to the unseen choreography. Even distant stars might sense the changing gravitational field, their paths minutely shifted by the combined mass now moving in tandem. The environment around the black holes begins to change subtly. Space itself is being rocked ever so slightly by their motion. The speed of their orbit climbs and climbs. What once took years now might take mere minutes. Eventually, the black holes are so close that they orbit each other many times in the span of a single day. And still they draw nearer. They have fallen into a deep gravitational well of their own making, circling faster and faster as they descend. There is a majesty in this furious pace. Two dark giants locked in each other's grip, sweeping around like twin stars, but with no light, only the distortion of space-time marking their presence. Through all of this, the outside universe continues largely undisturbed. To a distant observer with no special instruments, nothing visible betrays the drama unfolding. The stars in the sky remain steady pinpoints. The black hole's dance does not produce a flash of light or a burst of radiation that ordinary eyes could see. It is an invisible crescendo. Only those versed in gravity's subtleties would detect the mounting excitement, the ever-tightening orbit, and the intensifying gravitational waves. Those gravitational waves now carry away significant energy. The black holes have no choice but to spiral closer as they lose this energy. In a way, the waves are the music to which they dance. And as the music grows louder, the partners spin faster and come closer together. The pitch of that gravitational song sweeps upward as orbit after orbit. The black holes move quicker, radiating more and more of their kinetic energy away into space. At this stage, the energy being shed is enormous, enough to jostle massive objects across galaxies, albeit faintly. Yet it still happens in perfect silence and in perfect darkness. The power being released is in a form that is all but imperceptible unless you are looking with instruments attuned to the fabric of space-time itself. The universe, though, is beginning to take notice through those ripples. They spread outwards like the rings from a stone dropped in a cosmic pond, announcing that two great masses are in their final dance. Faster and faster the black holes whirl. Their orbits shrink from minutes to seconds. In their final orbits, they are moving at incredible velocities, a significant fraction of the speed of light. Imagine these two dark objects, each perhaps a few tens of kilometers across, but containing the mass of dozens of suns, now only a few hundred kilometers apart, spinning around each other dozens of times each second. They are like twin black marbles caught in a gravitational whirlpool, rushing around each other in a blur. By now, the gravitational waves are a crescendo, a high ringing tone in the fabric of space that climbs ever higher in frequency. The cosmos braces for the finale of this eons-long dance. All the while, from our viewpoint, the scene remains eerily calm and beautiful. Two black holes about to merge, space around them rippling outward, and not a single photon of light escaping to announce what is about to happen. The climax draws near. After an almost unimaginable span of time spent in spiraling courtship, the black holes are on the verge of finally becoming one. Their last few orbits flash by in less than the blink of an eye. What began as a slow, stately dance is now a wild, elegant whirlwind. In the next fleeting moment of cosmic time, these two will complete their grand performance. The ultimate embrace is imminent. The black holes are poised on the edge of coalescence, and the silent music of their dance has reached a fever pitch. In the stillness of the vacuum, a moment of truth arrives. The moment when two will become one. Without a sound, without a flash, the final step begins. In an instant that has been billions of years in the making, the two black holes finally become one. As they complete their last orbit, they plunge together and merge. The event is both extraordinarily violent and eerily silent. In that final fraction of a second, space-time around them erupts in a frenzy of motion. The two event horizons, those invisible spheres around each black hole, stretch, then meld into a single larger surface, like two soap bubbles fusing into one. The very shape of space contorts and oscillates wildly as the black holes coalesce. This is the climax of their long dance, a moment so brief, yet so powerful that it defies comprehension. For a fleeting moment, a storm rages in the fabric of the universe. If we could see gravity, we would witness something like a black ocean surface roiling with waves. The newly formed single black hole quivers with the energy of the collision, much like a ringing bell. It has absorbed almost all of the mass of its two progenitors. But even this mighty object cannot contain all the energy that was in their orbital motion. A tremendous amount of that energy is flung outward in the form of gravitational waves. These waves surge outwards in every direction, carrying away the excess energy of the merger. The power of this moment is beyond anything else known. For a brief fraction of a second, the energy released by the merging black holes, all in the form of those space-time ripples, exceeds the output of light from all the stars in the observable universe combined. It's a flood of pure gravitational energy, 50 times more luminous than all the galaxies together, yet it arrives not with a blinding flash, but as a distortion of space itself. And yet, astonishingly, there is no flash of light, no burst of radiation that our eyes or telescopes would see. Not any visible light, nor X-rays, nor gamma rays. No electromagnetic waves at all escape from this merger, only the profound vibrations of space-time. It is a cataclysm in complete darkness, a monumental event carried on waves that pass effortlessly through matter, whispering only to those prepared to listen. As the gravitational waves rush out, the two black holes' union is consummated. Where there were two distinct centers of gravity, now there is one. The new black hole, born from this merger, is slightly less massive than the sum of its parents. A few solar masses worth of material has effectively been converted into the energy of gravitational waves and sent off into the universe. The remaining mass sits in one black hole that is larger and more massive than either of the originals. In the aftermath, this single black hole is left vibrating like a struck gong. It oscillates briefly, a phase we call ring down, emitting a last series of diminishing gravitational wave tones as it settles. These final tremors carry away the small asymmetries of the newly formed black hole, smoothing it into a perfectly stable form. Then, astonishingly quickly, it is over. The storm in space-time subsides almost as fast as it arose. Within a few heartbeats, the ripples weaken and the new black hole stops ringing. It becomes quiet and steady, simply a larger black hole now standing alone. The merger that took eons to prepare has flashed by in less than a second. The climax, though ferocious in magnitude, was over almost before it began. All around, the universe returns to its deep quiet. The space that was violently stirred calms down, leaving only the steady gravitational field of the merged black hole behind. If one were nearby, though safely outside the danger zone, one would feel no hint of the titanic event that just occurred, aside from perhaps a gentle gravitational wave passing through. There is no debris left behind, nothing like the dramatic remnants of a supernova explosion. Two black holes simply became one, and in doing so, released a torrent of invisible energy. For the black holes themselves, this is the end of the dance and the beginning of something new. Their identities, in a sense, have fused. There is no longer two. Only one black hole remains, carrying on its existence. It carries with it the mass and momentum of both former holes, and it likely spins rapidly, having inherited the angular momentum of the orbital dance. One might poetically say that the two black holes have embraced and will never part. They have become one body, one profound warp in space-time where once there were two. Sometimes, when the two black holes do not merge in perfect symmetry, the newly formed black hole can receive a small recoil, a subtle kick that sets it gliding through space. In that case, the single black hole would quietly slip away from the exact spot of its birth, carrying on an onward journey. But in the vast emptiness, this change in position is almost meaningless. There are no landmarks in the void, and whether it drifts or stays, the black hole remains enveloped in darkness, continuing its existence as if nothing at all had happened. In the wake of this union, the surrounding space is calm again. The gravitational waves that momentarily shook the cosmos are already far beyond, racing outward at the speed of light. The drama at the center has concluded, and a great silence falls over the scene. The new black hole simply remains, as silent and dark as its parents were. Only now it is mightier, and for a short time it might wobble slightly before regaining perfect symmetry. What we have just witnessed is one of the most powerful events in the universe, yet one of the most serene in its aftermath. No light, no explosion visible from afar, just a silent convergence followed by darkness. It's humbling to realize that such an extreme act of nature can occur so quietly. The merger is complete. The dance, as we knew it, has ended in an unfathomably strong but soundless crescendo. Now all that's left to observe are the ripples from this event, carrying the story of these two black holes' final dance out into the universe. Far away from the merger site, the gravitational waves race outward into the depths of space. These ripples spread like concentric circles on a calm pond. Except this pond is the fabric of space-time itself, and the ripples travel at the speed of light, through galaxies and across the silent reaches between them. The waves propagate. As they pass by stars and planets, they gently stretch and squeeze space by infinitesimal amounts, too small to disturb anything but the most delicate measurements. Entire nebulae, clusters of stars, and clouds of gas are traversed by this fleeting distortion, and yet they show no obvious sign of it. The waves slip through everything, whispering the news of the black hole's collision in a language only the universe can directly hear. Though faint by the time they have travelled afar, these gravitational waves carry with them a story. Encoded in their shape and frequency is the tale of two black holes that danced and became one. The rising pitch and fading tail of the wave signal holds the memory of their masses and the speed of their final embrace. It's as if the universe has recorded the event in these waves, preserving it as they journey outward. Perhaps on some far-flung world, eons hence, a sensitive instrument will tremble just so, alerted by the ghostly passing of these waves. From that tiny tremble, curious minds could reconstruct the grand cosmic dance that occurred so many light years away and long ago. In this way, the black hole's final performance will not be lost to the void. It will be known and remembered, even if by strangers who never saw the event with light. Meanwhile, the newborn single black hole left behind continues its existence in solitude. The turmoil of the merger has settled, and it now drifts quietly through space, much like each did before they met. In time, this black hole may wander through the galaxy as its parents once did. It may sink toward the center of the galaxy, or join a cluster, or simply roam the outskirts. Who is to say what its future holds? Perhaps, billions of years from now, it might encounter yet another black hole and enter into a new dance of its own. In the cosmic timescale, such encounters, though incredibly rare, are not impossible. The dance of black holes might play out again and again, gradually building ever larger black holes as the universe ages. In the far future, many of the stars in the sky will be gone. Black holes, neutron stars, and other dark remnants will dominate the scene. Those great black holes will wander the quiet, starless expanses, occasionally finding each other and merging, just as our two travellers did. In this way, the cosmic ballet continues, even as the universe grows old. And in the hearts of galaxies, colossal black holes, millions of times the mass of the Sun, may spiral together as well, especially when galaxies themselves collide. These giant black holes merge amidst whirling disks of hot gas and stars, shaping the destiny of entire galactic cores. They too release powerful gravitational waves, even grander versions of the cosmic whispers we've been following. Yet, like their smaller counterparts, these immense events unfold in the same quiet language of gravity. They remain largely hidden from ordinary telescopes, revealed mainly by the motions of stars around them and the subtle ripples they send through spacetime. Even on this vast scale, the dance of black holes retains its silent, majestic character. Under the same night sky that we started with, all seems as serene as ever. If you look up on a clear, dark night, you will see the calm stars twinkling, unaware to your eyes of the dramas unfolding in the invisible realms. Yet now we know that hidden beneath that tranquility are cosmic dances and collisions that shape the universe. Somewhere, right now, in some distant galaxy, two black holes may be beginning their slow approach, just as ours did so long ago. Somewhere else, two different black holes might be in the final throes of merging, sending out new waves that will one day wash over places far away. The universe is vast enough for countless such dances to be at various stages, all at once. This realization does not break the peacefulness of the night. Rather, it enriches it. The cosmos remains a place of deep, profound calm on the grand scale. But within that calm, wondrous things happen in silence. We are cradled in a quiet galaxy, on a quiet world. But now and then, The cosmos whispers to us of its hidden events, like the merging of black holes through those faint gravitational murmurs. In the cosmos, every ending carries within it the seed of a new beginning. The death of a massive star gave birth to a black hole. The union of two black holes gave birth to a larger, mightier one. Creation and transformation are intertwined in this celestial ballet. Nothing is truly lost in these processes. Starlight becomes darkness, two entities become one, and energy is dispersed to be absorbed elsewhere. The universe continually renews and reshapes itself in silence, through cycles both gentle and grand, and in this way, the story endlessly continues. Our tale of the black hole's dance comes to an end here, in this meditative silence. The music of their union, the gravitational waves, has faded to a hush, and all is quiet once more. But the memory of their dance lives on in the universe and within us, as a reminder of the remarkable, hidden choreography constantly playing out in the cosmos. In the darkness of space, in the calm of night, the dance of the black holes continues, on and on, a beautiful, silent ballet written in the fabric of the universe itself. With that thought, we return to the peaceful night, our minds full of the cosmic wonders that lie hidden in the silence above. As our journey continues, we drift away from the realm of stellar black holes and their fleeting dances. We turn toward the calm centers of galaxies, where colossal black holes reside in silent vigil. These are the giants of the cosmos, millions, even billions, of times the mass of our sun. Each one sits at the heart of its galaxy, a dark anchor around which the entire starry city slowly swirls. Nearly every sizable galaxy we know of harbours such a supermassive black hole in its core. They appear to be an essential part of galactic architecture, a common thread woven through the cosmos. In some galaxies, these central black holes are unimaginably massive, not just millions, but billions of solar masses. The largest of them, found in the cores of giant elliptical galaxies, can reach tens of billions of times the Sun's mass. Yet, for all that mass, the black hole remains minuscule compared to its host galaxy, like a single grain of sand with the weight of a mountain, quietly influencing the swirl of stars around it. It is almost inconceivable, the scale of these black holes. Imagine crushing millions of suns into a space no larger than a single star system. All that mass, compressed into an infinitesimal volume, creates a gravitational pull that is overwhelming. The surface of a supermassive black hole, the event horizon marking the boundary beyond which nothing can return, might span only a few times the distance from our Sun to Pluto. Within that boundary lies the mass of millions of stars, an abyss of incredible density hidden in the dark. In a typical galaxy's core, a supermassive black hole lies cloaked amid swirling clouds of dust and clusters of ancient stars. Often it is quiet, a dormant giant that barely reveals itself. Stars in the inner galaxy orbit under the influence of this central mass, whipping around the black hole at astonishing speeds, like fireflies caught in a silent whirlwind. Yet from afar, the galaxy's heart appears tranquil, a still and mysterious centre in a vast pinwheel of starlight. Though the black hole itself emits no light, its presence can be discerned by its effects. Sometimes, if we look closely at the region around a galactic centre, we see strange distortions in starlight. The black hole's immense gravity bends light like a lens, causing the images of distant stars behind it to smear into arcs or rings of light. We also witness stars moving in odd ways. Some hurtle around an unseen object, looping in tight orbits that defy explanation unless one realizes a massive black hole lurks there. In these subtle clues, the hidden titan at the galaxy's core makes itself known. On rare occasions, the giant awakens dramatically. If a star or a cloud of gas ventures too close, it is captured by the black hole's gravity and drawn in. One can imagine the fate of an unlucky star that drifts too near. First, the black hole's gravity grasps the star more strongly on its nearer side than its farther side, stretching it apart in a process called tidal disruption. The star elongates into a stream of gas. It is literally pulled to pieces. Some of that gas will swirl into the black hole, heating to millions of degrees and creating a flare of X-rays and ultraviolet light that outshines the entire galaxy for a short time. The rest of the star's material is flung away in great arcs back into the galaxy. For a brief period, perhaps weeks or months, the galactic core blazes with the light of the shredded star, a beacon visible across cosmic distances. Then, as the last of the star's remnants disappear past the event horizon or disperse, the glow fades and the black hole returns to its quiescence. During such episodes, the galactic center may blaze with radiant energy, becoming a brilliant quasar or an active galactic nucleus that shines across space. Great jets of radiation and particles can erupt from near the black hole as some of the infalling matter is redirected outward, creating beams that shoot tens of thousands of light years into the intergalactic void. Such eruptions are not merely fireworks. They can dramatically affect the black hole's galactic home. The intense radiation and winds from a quasar can heat surrounding gas and even blow it out of the galactic core. By driving away the raw material from which new stars form, an active black hole can momentarily halt the birth of stars in its vicinity. Thus, when awakened, these giants can influence the evolution of their entire galaxy, regulating it, in a sense, ensuring that the galaxy does not produce stars too rapidly. But even in this active state, the black hole itself remains unseen, its body of darkness hidden behind a veil of brilliant light. Over the eons, these supermassive black holes grew to their tremendous sizes by consuming matter and merging with other black holes. In the early epochs of the universe, they might have begun as much smaller entities, perhaps the collapsed remnants of the first generation of stars, or primordial black holes born in the young cosmos. Gradually, they pulled in gas, dust, stars, and even other black holes that wandered near. Each meal and each merger made them heavier and more powerful. Across billions of years, these black holes swelled into the behemoths we find now at galactic centers, ancient, patient giants anchoring the cores of galaxies. Most of the time, however, a supermassive black hole is a silent ruler. It simply sits in its darkness, exerting a steady pull on the stars around it and subtly influencing the dance of the entire galaxy. In our own Milky Way, a giant black hole, about 4 million times the mass of the Sun, lies in wait at the center. Astronomers have named this object Sagittarius A, and it sits roughly 26,000 light-years from Earth, hidden behind clouds of galactic dust in the direction of the Sagittarius constellation. Most of the year, it slumbers quietly, indistinguishable amid the crowded central stars. We know it's there because we have seen stars near the galactic core whipping around an invisible point, moving at incredible speeds, as if driven by a cosmic whip. One star in particular, has been observed completing a full orbit in just about 16 years, an eye blink on galactic timescales, circling an apparent emptiness that can only be explained by a huge black hole lurking in the dark. Despite its vast mass, the influence of this black hole extends only over the innermost region of the galaxy. Interestingly, despite their titanic mass, these central black holes typically make up only a tiny fraction of the mass of their host galaxies. Our Milky Way's black hole, for instance, is less than 1 part in a million of the galaxy's total mass. Most of the galaxy's mass resides in its stars and in a vast halo of invisible dark matter. Yet what the black hole lacks in overall share, it makes up for in influence at the core. Within a few light years of the center, it is the dominant force controlling the orbits of nearby stars. To the billions of stars farther out, it is just a calm centerpiece, a heavy presence that helps keep the galaxy's core intact, but one that doesn't notably affect the day-to-day existence of star systems far from the center. For ages, these colossal black holes reign alone at their galactic centers, each one the solitary monarch of its domain. Yet, in the vastness of space, even monarchs may one day encounter others. Galaxies themselves do not remain isolated indefinitely. They drift and wander, slowly drawn by the gravitational pull of their neighbors and the unseen currents of dark matter. And when two galaxies begin to approach each other, their stars and gas will intermingle. The quiet reign of each galaxy's central black hole is destined to be interrupted. The stage is set for an encounter between the great black holes at their cores, a meeting that will unfold over an almost unimaginable span of time and change the galaxies forever. Now, across the silent sea of the cosmos, imagine two galaxies on a slow collision course. Each galaxy carries a supermassive black hole in its core, like a precious secret at its heart. At first, the galaxies are separated by immense distances, gliding toward one another with an almost imperceptible motion. Over billions of years, they come closer. From our perspective, it is a dance so slow it's nearly frozen in time, a gradual drift guided by the gentle but inexorable pull of gravity. In fact, our own galaxy is fated to experience such an event. The Milky Way and the neighboring Andromeda galaxy are on a path toward each other, destined to collide in about 4 billion years. If there were observers in that far future, they would see Andromeda as a faint, silvery patch of light that gradually grows larger in the night sky. Century by century, millennium by millennium, its glow would intensify. Over long epochs, that hazy form would spread and stretch until it dominates the heavens, a swirling congregation of stars on a slow-motion collision course with our own. At first, that hazy glow of the approaching galaxy would be just a subtle addition to the familiar constellations. As millennia pass, it would grow into a distinct band of light, like a second Milky Way crossing the sky. Eventually, during the closest approach, 2 majestic swirls of stars might be visible at once, their shapes distended and overlapping. The sky could become a breathtaking tapestry of stars and nebulae from both galaxies mingling together. New constellations would form and fade as the heavens evolve. By the time the galaxies fully merge into one, the concept of a familiar night sky would be completely transformed. No longer would there be a narrow ribbon of starry light marking the old galactic plane. Instead, a more uniform, all-sky glow of countless stars would spread across the heavens, the end product of 2 star systems becoming one. As the galaxies draw nearer, their shapes begin to distort under each other's gravitational influence. Delicate tidal forces reach across the widening gulf between them, tugging at the stars and gas on the galaxy's outskirts. The spiral arms of each galaxy start to stretch and bend. Long streamers of stars, tidal tails, are pulled out, arcing into the darkness like luminous ribbons fluttering in a cosmic breeze. Within the galaxies, the familiar order is disrupted. Some stars are yanked from their comfortable orbits and flung into intergalactic space, destined to wander the void as solitary travelers. Others are sent on wildly elongated paths that carry them far from their original neighborhoods. Clouds of gas, once peacefully orbiting, are compressed and twisted, igniting bursts of new star formation. Massive newborn stars, hot and blue-white, flare to life amid the turmoil, while older, cooler stars glow in hues of red and orange. It creates a striking palette in the merging galaxies, brilliant clusters of young blue stars, shining like firework sparks against a backdrop of redder ancient ones. Brilliant clusters of newborn stars light up areas of the galaxies like festive fireworks against a velvet sky. Astronomers have even observed galaxies caught in such an embrace. In photographs from powerful telescopes, we see pairs of galaxies connected by luminous bridges of stars and gas. One famous duo, nicknamed the Antennae Galaxies, shows long, graceful tidal tails stretching out like insect antennae where two spirals are merging. These real cosmic images are snapshots of a slow dance mid-step, offering us a glimpse of what our imagined collision might look like from afar. Despite these disruptions, neither galaxy is destroyed at the first encounter. Instead, they begin a graceful cosmic waltz around their shared center of mass. They may pass through one another, then drift apart slightly, only to be drawn back together again by their mutual gravity. Each encounter weaves them more tightly together. Over hundreds of millions of years, the dance continues, an elaborate slow choreography of stars and gas. All told, the merging of two large galaxies might take on the order of 1 billion years or more from the first tentative approach to the final coalescence. The once distinct spirals become ever more entangled. Bright nebulae are jolted and merged, while streams of starlight connect the two galaxies like tenuous bridges. With each pass, the galaxies exchange more of their stars, and their identities blur a little further, like two dancers coming into closer and closer step with every turn. For any civilization within those galaxies, the changing sky would be both awe-inspiring and disorienting. On a world orbiting a distant star, the night might once have been a familiar canvas of constellations. But as the galaxies intermingle, that canvas transforms. A hazy band of light, once the other galaxy seen from afar, would grow to become a spectacular arch across the sky, outshining even the Milky Way's own starry ribbon. As eons pass, that arch would spread into an expansive panorama of light. New stars ignited by the merger would dot the heavens, and clouds of colourful nebulae would bloom where galactic gas clouds collide and coalesce. The heavens would be in flux, old familiar star patterns dissolving, replaced by swirls and patches of nebulous glow never seen before. It would be a sky in transition, alive with evidence of cosmic change. Gravitational tides from the interacting galaxies could also disturb the distant comet reservoirs of planetary systems, sending some icy bodies on trajectories that carry them inward. On an affected world, one might see an increased flurry of comets blazing across the sky and more frequent meteor showers, a gentle rain of celestial wanderers stirred loose by the galactic tide. The heavens would no longer look the same. They would be alive with the imprint of the grand slow dance unfolding above, a testament to a cosmic process playing out on timescales far beyond human lifetimes. In the midst of this cosmic dance, The central regions of the galaxies are also profoundly affected. The gravitational disturbance of the merger can funnel gas toward each galaxy's core. As that gas swirls inward, it may awaken the sleeping giant black holes. They begin to feed on the influx of material, and in doing so, they light up. During this phase, the merging system briefly sports two brilliant hearts instead of one. The two black holes, each surrounded by their own radiant accretion disks of superheated gas. The galactic centers that were once dark now shine brilliantly as quasars, pouring out torrents of energy. Jets of matter and radiation shoot from the poles of the swirling disks around the black holes, adding dramatic, lighthouse-like beams to the scene. For a time, each galactic core becomes a beacon outshining its entire galaxy with the luminosity of trillions of suns, even as the slow merger continues to unfold around it. Eventually, the two galaxies coalesce more completely. The violent bursts of star formation gradually subside as the remaining gas is either consumed or ejected into space. What began as two separate systems becomes one larger, amorphous galaxy. The graceful spiral arms that once defined each galaxy are now twisted beyond recognition or have dissolved entirely. The product of the merger might resemble a giant elliptical galaxy, a vast, rounded cloud of stars with a bright core and a hazy, diffuse edge. Traces of the collision linger in the form of shells and arcs of stars on the outskirts, like cosmic ripples that attest to the upheaval that has taken place. The distinct spiral patterns are gone, replaced by a more featureless distribution of stars. The galaxy's overall light has a smoother, more uniform glow as the populations of stars from both galaxies settle into a new combined equilibrium. And yet, at the center of this newly formed galaxy, something extraordinary is taking place. There is no longer a single galactic nucleus with one black hole commanding the stars. Now there are two supermassive black holes brought into dangerously close proximity by the union of their host galaxies. After ages of reigning in separate realms, each black hole now finds itself within the gravitational influence of the other, like two mighty monarchs suddenly forced to share one throne. They remain far apart at first. Perhaps thousands of light years still lie between them. So for a time they circle distantly, each king in a castle of stars, aware of the other's presence. But their fates are now entwined. The stage is set for an encounter of unimaginable scale, a direct interaction between two supermassive black holes deep in the heart of the merged galaxy. Galactic mergers like this have occurred throughout cosmic history, serving as one of the primary ways that galaxies grow and evolve. In the early universe, countless smaller proto-galaxies came together to form the large galaxies we see today, repeating this slow, stately dance over and over. Each time galaxies unite, their central black holes eventually meet as well, replaying the cosmic dance of titans anew. Now, in the core of our merged galaxy, we arrive at that crucial moment, the beginning of the direct engagement between two black holes that have long been destined to converge. Astronomers have observed hints of such arrangements in the universe. A few distant galaxies appear to have double bright cores or peculiar flickering light patterns, suggesting two supermassive black holes locked in orbit, slowly spiraling toward each other. These are thought to be galaxies in mid-merge, where the central giants haven't yet joined, but are well on their way. In our scenario, at first the two black holes remain far apart within their merged galaxy, orbiting one another at a distance. They move in a stately loop, taking tens of thousands or even millions of years to complete a single circuit. Yet they are now bound by their mutual gravity, connected in an elaborate dance that has only just begun. There is no turning back now. Caught in each other's gravitational embrace, their fates are sealed. It may take an incomprehensibly long time by human reckoning, but the outcome is inevitable. Gravity will draw them together, inch by inch, until they become one. Time means little to these dark giants. Centuries pass like fleeting moments in their journey. In the early phase of their orbit, the motion is so slow as to be almost imperceptible. The black holes might be separated by tens of thousands of light years, moving with such deliberate slowness that it would take ages for the pattern of their dance to noticeably change. But with each passing millennium, they draw a little closer. Their mutual gravitational pull gradually overcomes any remaining momentum carrying them around. They begin to drift inward, spiraling around a common center, two immense shadows circling in darkness, locked together by forces of nature that neither can escape. As they draw nearer over the course of millennia, their orbit quickens, and the character of their dance begins to change. What once took unimaginable spans of time now happens faster. When they are perhaps only a few hundred light years apart, an orbit might be completed in mere hundreds of thousands of years. Closer still, say tens of light years apart, and each orbit might take just thousands of years. Though such periods are still enormous to mortal beings, to the black holes, they are the steady ticking of a slow cosmic clock, counting down to an inevitable union. Throughout these eons of slow change, the rest of the galaxy continues largely unaware of the drama at its core. For any observers living on planets orbiting stars far from the center, the black hole's courtship is invisible and silent. Their nights are illuminated by the usual stars, and perhaps the diffuse glow of the dense galactic nucleus. But nothing obvious reveals that two gargantuan black holes are slowly twirling towards each other in that distant glow. Only the most subtle clues exist. A slight perturbation in the orbits of stars very near the core, or an unusual flicker of energy from the galactic center. Hints that would be discernible only to advanced instruments and keen insight. To ordinary eyes and everyday life in the galaxy's outer reaches, everything would seem as it always was, oblivious to the slow-motion destiny unfolding in the depths of the galaxy. Throughout this long courtship, the black holes influence their surroundings in subtle but significant ways. They are like two whirlpools forming in a vast sea of stars. As they circle one another, their combined gravity stirs the starry environment around them. Any star that strays too near the orbiting pair can be caught in a gravitational tug-of-war. Some of those stars are flung outward at tremendous speeds, slingshotted into wider orbits, or even tossed entirely out of the galaxy, becoming exiles in intergalactic space. With each star that is ejected or deflected, the black holes lose a tiny bit of their orbital energy carried away by the departing star. This acts like a brake on their dance, causing them to drift imperceptibly closer together. In this way, the dance, once driven only by their mutual gravity, is assisted by interactions with their stellar audience. It's a subtle exchange. The two black holes, through gravitational encounters, gradually clear out the innermost region of stars, and each such encounter brings the partners nearer to each other. If there is any gas left near the galactic center, it too is swept up into the choreography. Wisps of remaining nebulae might form a rotating disk encircling the dancing black holes, a faintly glowing ring illuminated by the feeble light of heated dust. Occasionally, as the black holes orbit, their gravitational forces jostle this disk of gas, sending a ripple through it. The gas may respond by radiating a soft pulse of X-rays or radio waves, a gentle signal that something is there, twirling unseen in the darkness. These signals are sporadic and weak, nothing like the ferocious blaze of the quasars that flared during the galaxy's merger. They are more like the dim embers of a fire that once raged fiercely. Mostly, the two black holes continue their approach in near darkness, accompanied by only the gravitational music of their spiral dance. For millions upon millions of years, the black holes spiral toward each other, slowly picking up speed. What began as a stately waltz becomes a more urgent dance as they draw closer. By the time their separation closes to just a few light years, each orbit might take only a few centuries. From a distant vantage, one might now perceive a subtle wobble in the heart of the galaxy, a tiny cyclic motion of the innermost star orbits perhaps, hinting that a massive binary is at work. If we could see gravitational forces, we would witness an intricate ballet. The very fabric of space is curving and twisting around these two masses, swirling as the black holes move in their tightening orbit. And indeed, even though the black holes remain invisible in ordinary light, they are sending out a form of signal as they dance. With each orbit, they create ripples in the very fabric of space and time, gravitational waves that spread outward in all directions. It's akin to two dancers moving on the surface of a still pond. Their motion sends gentle waves across the water. But here, the water is space-time itself, and the waves are distortions of distance and time emanating from the orbiting pair. At first, these gravitational ripples are unbelievably weak, far beyond the detection of any conceivable observers light years away. They are like the softest whisper in a vast, noisy theatre. But as the black holes draw closer and move faster, the whisper grows to a murmur, then to a clear voice, and finally toward a resounding crescendo. Slowly, inexorably, the distance between the two black holes shrinks. From a few light years to a fraction of a light year, and then to mere light months, the gap closes. Their mutual orbit tightens into a faster and faster whirl. What once took millennia now takes mere years. What took years shrinks to months, then weeks. The acceleration is breathtaking. In these final stages, the black holes may be only a few billion kilometers apart, comparable to the size of a star system or smaller. At that range, they whirl around each other many times in a single year, then many times in a month, drawing closer with each passing day. Their speeds reach an astonishing fraction of the speed of light. They chase each other in smaller and smaller circles like twin storm clouds on a collision course. All the while, the gravitational waves they emit grow stronger and more rapid, no longer mere whispers, but rising toward a deep, cosmic song, a low, resonant humming of space-time that carries immense energy. Yet for all this fury of motion, to most outside observers with conventional eyes and instruments, there might still be very little to see. Perhaps a slight flicker of light, if some last bit of gas is caught and heated, or an unusual movement of a few stars near the core, hinting that something extraordinary is happening. But largely, the impending merger unfolds hidden in darkness, with only the fabric of the universe itself as a witness via the language of gravity. If somehow an observer could safely drift in space relatively near the orbiting black holes, the visual spectacle would defy imagination. They would not see the black holes directly, only the absence of light where each one lurks. but the effects on the surrounding starlight would be dramatic. Background stars on the far side of the black holes would appear as smears and rings of light encircling the darkness, a gravitational lensing effect taken to an extreme. As the black holes circle each other, these warped rings of light would twist and dance as well, swirling around the unseen dancers. It would be like peering through a funhouse mirror that is itself in motion, points of light stretching into arcs, then snapping back, only to stretch again as the tremendous gravity bends the path of every passing beam of starlight. Occasionally, if the alignment were just right, one might even see a sudden flash as the light of a distant star is focused and intensified for a moment by the moving gravitational lenses, a cosmic mirage flickering in time with the orbit. All around, space itself would seem to ripple subtly with the torrent of gravitational waves, though these distortions of space would be imperceptible to human senses. Our intrepid nearby observer might feel nothing in their body at all. Yet sensitive instruments would register the stretching and squeezing of space. In the silent, surreal ballet before them, two voids circle and converge, warping everything around them in a gravitational trance. The two black holes are now locked in the tightest of embraces. Their orbit is a rapid blur, and only a final act remains. What was once a gentle courtship has transformed into a wild, dizzying whirl. In a sense, the entire process has been a long crescendo, building up to a climax that is now only moments away. The black holes have reached the point of no return. They can no longer orbit stably. With each millisecond, they plunge closer. After millions of years of approach, the final seconds of their dance arrive at last. The universe itself holds its breath as the courtship of giants is about to give way to the triumphant finale of their union. And then, the moment of the ultimate merger arrives. For ages upon ages, gravity has orchestrated this meeting, and now the final act unfolds in mere heartbeats. After a long journey of convergence, the two black holes meet at last. In the final fraction of a second, before they become one, they are orbiting each other at incredible speed, perhaps half the speed of light or more. Their masses, each unfathomably heavy, draw irresistibly together. In a heartbeat of cosmic time, the two black holes collide and coalesce. They do not crash like solid objects, for they are realms of pure gravity. Rather, they merge as droplets of ink might merge in water, seamlessly and swiftly. As their event horizons touch, they form a single, larger horizon that engulfs them both. Two become one. In that instant, a powerful shock of gravitational waves is launched into the universe. Space-time, stretched to its limit by the final dance, now recoils and springs outward, sending concentric ripples racing away from the collision site. For a brief moment, the power radiating from this collision is greater than that of all the stars in the observable universe combined. All that energy surges out, not as light, but as gravitational waves, tremendous vibrations of space-time hurtling outward at the speed of light. This outburst of energy comes at the expense of mass. A portion of the black hole's own mass is instantly converted into gravitational wave energy by the force of the merger. In that blink of an eye, an amount of matter equivalent to several suns is annihilated, transformed into pure gravitational radiation and carried off by the waves into space. It is a transformation on a scale that defies ordinary imagination, a direct realization of Einstein's famous equation E = mc2 on a cosmic stage, turning mass into energy in an instant. The newly formed single black hole that results is stupendously massive, more massive than either of the original two, though slightly less than their sum, since a few % of their combined mass was shed as energy in those gravitational waves. In the aftermath of the merger, the new black hole is momentarily distorted. It's not a perfect sphere yet. It bulges and vibrates from the force of the collision, like a struck bell reverberating, or a disturbed water droplet trying to become round. This phase is known as the ring down, when the black hole sheds its deformations and settles into a stable shape. It oscillates between slightly distorted forms, and with each oscillation, more gravitational waves are cast off, carrying away the excess energy of its vibration. Much like a gong that has been struck, the vibrations diminish with each passing moment. The black hole radiates its remaining jittery energy as gravitational waves until it becomes quiescent and perfectly round once again. Deep within the merged black hole's event horizon, any trace of the two original entities is lost. Whatever tumult or transformation occurred inside is forever hidden from the outside universe, sealed behind that one-way door of gravity. Not even the titanic convulsion of their union can reveal what lies within that darkness. It remains one of the cosmos's enduring mysteries. All that can be known is told by the waves and motions we observe outside the horizon. To any outside observer still watching for light, there is little drama to witness directly. Perhaps, if some residual gas was orbiting the pair, one might see a brief, final flash, an outburst of light as that gas is suddenly compressed and heated by the merging of the black hole's gravitational fields. There might be a momentary flare of X-rays or a burst of high-energy particles. A jet that one of the black holes had been emitting could wobble and then realign as the magnetic environment around the new black hole adjusts. But these electromagnetic signals, if they occur at all, are side notes, fleeting sparks compared to the colossal storm of gravitational energy that has just been unleashed. As the ringing black hole settles, its event horizon becomes calm and perfectly smooth once more. The single horizon now contains all the mass of both original black holes, minus that portion radiated away. Soon it stabilizes into a simple shape, a featureless sphere of darkness, as black holes always are, characterized only by its total mass and the spin it retained from the orbital dance. The new black hole likely carries a substantial spin, inherited from the angular momentum of the binary system. It may be rotating rapidly, space around it dragged and twisted by its rotation, but to any external view, it is simply a larger black hole, spinning in the void. In the darkness at the galaxy's core, equilibrium begins to return. The furious motion that preceded the merger ceases as everything is now captured by the single gravitational well of the new black hole. Space-time itself gradually stops quivering in the immediate vicinity. What remains is one enormously massive black hole, possibly with a swirling halo of debris around it. Stars and gas that survived the chaos and are now settling into new orbits under the influence of one central mass. The immediate violence is over in seconds, and a deep silence falls, at least in terms of gravitational disturbances. The ultimate merger is complete. A new titan now reigns in the galactic heart, born from the union of two. It may have recoiled or moved slightly due to asymmetry in the gravitational waves it emitted, like a cannon recoiling after firing a massive shot, causing the new black hole to lurch a bit off-center. In some cases, such recoil could be tremendous, potentially kicking a black hole thousands of light-years from its origin. In our case, the massive merged black hole might oscillate through the core or drift for a time, but given the enormous gravitational pull of the surrounding galaxy, it will eventually sink back toward the center, settling into the bottom of the galaxy's potential well. Any oscillation or displacement will damp out as it interacts with the stars and dark matter halo, until the giant comes to rest at the galaxy's core once again. For any observers situated light years away, even in neighboring galaxies, the direct visual of this event would likely have been unremarkable. They might notice that the once bright quasar at the galactic center has dimmed or changed as the two cores became one. Or they might see nothing at all with ordinary telescopes, since much of the spectacle was in gravitational waves, not light. Yet if those observers had instruments sensitive to gravity's ripples, they would register a clear signal, a sudden, resounding spike of gravitational waves washing over them, the unmistakable chirp in the fabric of spacetime that announces a black hole merger. In the blink of a cosmic eye, the black hole's dance has ended. The climax, though monumental in energy, was swift. Now the universe is left with a ringing echo of what transpired. The gravitational waves from this collision are spreading outward, carrying the news of the merger to the far reaches of space. They propagate as an expanding shell of distortion, growing ever larger and fainter as they travel. In those waves is encoded a record of the black hole's final performance, information about their masses, their last furious orbits, and the instant they became one. It's as if the black holes sang a duet in the language of gravity, and that song, compressed into a fleeting cascade of waves, is now travelling across the cosmos, waiting to be heard by anyone or anything capable of listening. The stage is set for the aftermath of these titans' merger. The galaxy around them will carry on into the future, forever changed by the events at its core, and the effects of this colossal union will continue to play out both near and far. In the aftermath of this titanic merger, the galaxy that hosts the newly formed black hole gradually settles into a quieter state. The violent motions and brilliant fireworks of the collision die down on cosmic timescales. The two galaxies that once were have become one, and their combined population of stars carries on, orbiting a center of gravity that now houses a single, supermassive black hole. Over time, the chaos in the core subsides. Stars that were flung into wildly different paths eventually either escape the galactic hub or find new, stable orbits around the unified center. What was once a maelstrom begins to calm. The immediate area around the black hole clears out somewhat. Many of the innermost stars were either swallowed or ejected during the long merger process. Bit by bit, order returns, in a fashion, to this cosmic city. At the very heart of the galaxy, the merged black hole now sits as the ultimate titan, calmly presiding over its domain. In the wake of the merger, it might indulge in a brief feast. Large amounts of gas and dust that were jarred loose during the final coalescence can now spiral inward toward the center. For a short while, the core of the galaxy could glimmer with renewed activity as that material accretes onto the black hole. A disk of hot, glowing gas may temporarily form around the black hole, and the giant may send out a pair of faint jets, last echoes of the feast, shooting into space. These are like the final fading embers of the once raging fire. The accretion disk shines, but far less brightly than during the peak of the merger. It is a gentle afterglow, rather than a blinding quasar. Before long, even those embers begin to cool. The fuel is largely spent. What isn't consumed by the black hole settles into orbit around it, or gets flung to the galaxy's outskirts. The new giant black hole slips back into quiescence, fading into the quiet darkness once more. The galaxy itself bears subtle marks and scars of the colossal event it experienced. its very shape has changed. The well-defined spiral structure it may have once boasted is gone, replaced by a more amorphous spread of stars. The distinct disk has puffed up, and many stars now trace random, elongated paths, giving the galaxy a more rounded, diffuse appearance. If one could view it from outside, they might notice huge, faint loops or shells of stars at the galaxy's periphery. These are the residue of the tidal forces from the collision, vast echoes of stars thrown out and now drifting back under gravity. Deep in the core, the distribution of stars has been reshaped by the merger. Many stars were slung outward by the gravitational thrashings of the binary black holes, leaving the innermost region somewhat more hollowed out than before. At the same time, some stars have settled into closer, tighter orbits around the now solitary black hole. The stellar heart of the galaxy has been both stirred up and thinned out by the violence of the merger, leaving behind kinematic patterns that subtly testify to the upheaval. All these changes are slight to an untrained eye. To most casual observers, the galaxy would simply look like an elliptical blob of starlight. But to astronomers piecing together the clues, the signs of a past collision and merger are written into the positions and motions of the stars. For any beings living in this galaxy, life continues. Generations of stars will rise and fall, planets will orbit their suns, and perhaps life on some of those planets will go on, largely unaffected by what transpired in the remote nucleus. But if those hypothetical inhabitants could compare the sky of the present to that of the distant past, they would note dramatic differences. The grand band of the Milky Way-like disk that might once have arched across their night sky could be gone, replaced by a more uniform haze of starlight in every direction. Where once there was a thick line of concentrated stars, the plane of the original galaxy, now the stars are distributed more evenly, creating a glowing background everywhere, without a distinct pattern. The central region of the galaxy, which may have shone intensely if the black hole was active, would have dimmed considerably after the merger's conclusion. Now the core might merely be a dense clustering of stars around an invisible mass. A quieter hearth, identifiable more by the rapid orbits of those stars than by any light of its own. Only with careful observation could one discern what happened, perhaps by noting the unusual motions of stars near the center, or by detecting streams of stars moving coherently at the galaxy's outskirts, evidence of the old tidal tales. To the naked eye, the galaxy has entered a calmer chapter, subtly different from before. While the merged galaxy quietly moves on with its new heart, the impact of the black hole's union is not confined to that galaxy alone. The gravitational waves that surged out at the moment of collision continue to travel outward, expanding through the universe like ever-widening circles on a pond. These ripples in space-time carry with them the story of what happened. Encoded in their undulations is information about the masses of the black holes, the speed and radius of their final orbits, the moment they merged. As these gravitational waves move through the cosmos, they grow fainter, dispersing their energy across an ever larger volume of space. Yet they remain a coherent disturbance, a travelling memory of the event. They pass through intergalactic space, racing through the darkness at light speed. Thousands of years, then millions of years go by, and still the waves spread further, covering distances measured in tens of millions of light years, then hundreds of millions. They wash over distant galaxies, and through those galaxies stars and planets, causing everything in their path to jiggle ever so slightly. Planets, dust clouds, and all of existence are gently rocked by the passage of these waves. As a gravitational wave rolls through a region of space, it causes distances to oscillate. Everything in its path is stretched a bit in one direction and compressed in the perpendicular direction, then stretched in the opposite way, back and forth, as the wave passes. If one could place a giant ruler between two stars, one would see it alternately lengthen and shrink by a minute amount as the wave went by, then return to its normal length once the ripple had passed. Such is the gentle, ghostly effect of these waves, profound in the energy they carry, yet so subtle in their influence on the worlds they touch. And yet the effect is so slight that it goes entirely unnoticed by any living creature. Even the most advanced civilizations would need extraordinarily sensitive instruments to detect such a passing tremor. Now imagine, far away on a quiet planet, orbiting an unremarkable star, eons after the black hole merger took place. On this blue-green world, our own Earth perhaps, intelligent beings have built devices of exquisite sensitivity, designed to listen for faint whispers from the cosmos. These instruments, resting quietly in their facilities, continually monitor the stretching and squeezing of space itself. When at last the gravitational waves from our titanic merger arrive at this distant corner of the universe, the instruments ever so slightly feel the tug. Space on that planet stretches and compresses in rhythm with the dying echoes of the black hole's dance. The signal is incredibly subtle, a tiny quiver that lasts only a short time, but it carries a distinctive pattern, a rising and then abruptly falling tone in the data that reveals its violent origin. The scientists watching their screens do not hear sound with their ears, but they see the telltale signature in their detectors' readings, a brief oscillation that stands out from the random noise of Earth's environment. It is the cosmic whisper from two black holes that merged billions of years ago, billions of light years away. For the observers on that far-off planet, this whisper is a revelation. It's as if the universe itself has spoken, not in words or light, but in the subtle stretching of space-time, relating a story from the depths of cosmic time. In this way, the merger of the two supermassive black holes, an event long over in its own galaxy, becomes known across the cosmos. The gravitational waves are messengers, bearing news that transcends time and distance. They tell anyone able to listen that in a remote galaxy, two giant black holes once whirled together in a lethal embrace and became one. In a sense, these waves underscore the profound connectedness of the cosmos. An event in one far-flung galaxy can produce an effect that travels across unimaginable distances to touch another corner of the universe. No part of space is truly isolated. Gravity weaves all of existence into one cosmic fabric, so that even the most distant happenings can eventually make themselves known elsewhere, however subtly. And this epic merger is but one of many. The universe has been quietly hosting such events for eons. Countless other black hole pairs have merged throughout cosmic history, each sending out its own set of gravitational waves. Space around us is likely crisscrossed with the faint echoes of ancient collisions, a cosmic symphony of low whispers from events long past. Most of these waves are far too weak for us to detect, a background hum of the cosmos. But they are there, overlapping and filling the universe with a tapestry of gravitational memories. The echoes from our particular event are just one song in a cosmic chorus. It's even possible that this dramatic dance will replay in the far future. The evolution of the universe is ongoing, and galaxies will continue to collide and merge under gravity's pull. Perhaps billions of years from now, The galaxy we've been envisioning will itself encounter yet another galaxy. If so, its central black hole, now enormously massive from its past merger, may one day find itself dancing with a new partner brought in by that next galactic union. In this way, black holes can grow ever larger over cosmic time through successive mergers and accretion, each event adding a chapter to the galaxy's story. The dance of black holes is not a one-time performance, but a recurring theme, as long as there are galaxies to meet and gravity to draw them together. For now, the new supermassive black hole remains at the center of its galaxy, a silent monument to the collision that shaped its world. The galaxy around it is calmer and altered, but stable once more, continuing to drift through the cosmos. Long after the galaxies involved in the collision have perhaps merged into larger structures or changed beyond recognition, the gravitational waves will still be traveling outward, carrying a record of that ancient event. In that sense, the universe itself remembers. Even when the site of the merger has moved on with time, the memory of it persists in the form of waves wandering the cosmos. Perhaps one day, those faint echoes will inspire the curious minds that detect them. By decoding the subtle signals, observers can picture the cosmic dance that gave them birth, piecing together the story of how two galaxies collided and their mighty black holes merged. It is humbling to realize that the gravitational waves now reaching our distant planet began their journey long before humans even existed. The collision that generated them happened in a time unfathomably remote. Yet by sensing these faint ripples today, intelligent beings can witness a moment from the deep past of the universe. In a way, these waves serve as a bridge across time and space, allowing ephemeral creatures like us to connect with events that occurred billions of years ago. The cosmos writes its history in light and gravity, and we are only just learning how to read those ancient chapters. All across the universe, change is the only constant. Galaxies collide and merge, black holes grow and transform, and new cosmic structures are born from the remnants of the old. What appears eternal and unchanging, like the steady spiral of a galaxy, can, given enough time, become the stage for dramatic evolution. These colossal mergers remind us that even on the grandest scales, creation and destruction are intertwined processes, driving the cosmos forward through time. And so, the echoes of the Titan's dance live on, spreading outward, weakening, but never fully disappearing. They will continue their journey indefinitely, even as the merged galaxy moves on to new stages of its life. And as the gentle ripples of this colossal event wash over distant worlds and the sensitive instruments listening on our own planet, the final act of this cosmic tale is about to unfold. The silent song of the merging black holes will be heard at last, and the universe will reveal its secrets to those prepared to listen. In the stillness that follows a cosmic collision, something profound is set in motion. Two black holes have just merged in a distant galaxy, their violent dance releasing a burst of energy unlike any other. Yet no light shines from this event. Only silent ripples carry the news of what transpired. These ripples, known as gravitational waves, spread outwards through the very fabric of space, moving at the speed of light. They travel in every direction, expanding across the vast darkness of the universe, steadily journeying away from the site of the merger. For billions of years, these gravitational waves glide through the cosmic void. They traverse regions of space where no stars shine, and pass through galaxies filled with billions of suns. Nothing halts their progress. They slip through nebulae and brush past clusters of galaxies, unaffected by the matter around them. Unlike sound waves that need air or water to travel, gravitational waves ripple through the emptiness of space itself. They are like ripples on a cosmic pond, except the pond is the fabric of spacetime, and the ripples carry on endlessly. As they travel, they grow ever fainter, their once mighty vibrations stretching out and diminishing with distance. But they never completely fade away. Across the cold, thin expanse of intergalactic space, they carry on, faithful messengers of a momentous event long past. Each wave is an echo of the black hole's final dance, moving outward in an eternal whisper. Now imagine one of these echoes arriving here, at our own small planet. After an almost incomprehensible journey, a gravitational wave reaches the Milky Way and washes over our solar system. It sweeps silently across the orbit of Neptune, passes by the bright sun, and continues toward Earth. On a quiet night, as our world turns gently beneath the stars, that ancient ripple finally encounters Earth. It does not announce itself with any flash or thunder. Instead, it slips through our planet so subtly that all life goes on unaware. In that moment, as the wave passes, the Earth itself is ever so slightly distorted. Space and time stretch and compress by a minuscule amount, far too small for any person or creature to notice. The distances on Earth change by a tiny fraction. The span of an ocean, the gap between mountains, even the space between the atoms in your body, all oscillate by an infinitesimal degree. It is as if the whole world takes a delicate, imperceptible breath. The fabric of reality quivers, oh so slightly, then returns to normal as the wave continues on its way into the dark. Imagine standing under the night sky at that moment. The air is calm, and the stars above are serene. Perhaps you feel a gentle breeze, or the subtle hush of nighttime. Nothing betrays the cosmic visitor that has just passed through. The gravitational wave has left no mark on the ground, no disturbance in the air. It has moved through you, through everything around you, and none of your senses knew it. These cosmic echoes arrive at Earth routinely, whispering past us without a sound. For eons, they went undetected, their faint messages passing through our world, unheard and unheeded. No human sense can feel them. No ordinary instrument can record them. They are ghostly visitors, remnants of distant dramas playing out beyond the reach of our eyes. And yet, despite their silence, they carry with them the story of that far-off collision. Each gravitational wave that sweeps through Earth is like a traveller from a distant land, bearing news of titanic events in the darkness beyond. For countless generations, we had no idea these travellers were passing by. The sky looked calm and still. The universe seemed silent, apart from the twinkle of stars and the glow of the moon. But that silence was an illusion. The cosmos was alive with subtle vibrations, with gentle ripples in space-time, weaving through the background of existence. Earth was bathing in this quiet cosmic music without ever perceiving it. Even now, as you listen to these words, one of those ancient ripples might be washing through you and everything around you, silent and unseen. They have always been there, waiting for us to notice them. It was only a matter of listening, of finding a way to sense the imperceptible. Humanity's curiosity and ingenuity would eventually lead us to build just such a way, allowing us at last to hear the cosmic whispers that have always been washing over our world, in our quest to uncover the hidden rhythms of the universe. Humanity, set out to build instruments capable of sensing the imperceptible in quiet, secluded places on Earth. Observatories, unlike any before, were constructed. They did not peer at the sky through lenses or dishes. Instead, they stretched out along the ground, 2 long tunnels arranged in a giant L shape, each arm kilometers in length. Inside these tunnels, a laser beam is sent racing back and forth between mirrors. This setup may not look like a traditional telescope, but it was designed to perform an extraordinary feat. By measuring the travel time of light in each tunnel with extreme precision, it can detect the slightest change in length of one arm compared to the other. In essence, these observatories are built to feel the stretching and squeezing of space itself. To achieve this, every other source of disturbance had to be silenced. The long tunnels are maintained in a near-perfect vacuum, so that no air can interfere with the laser's path. The mirrors, suspended by delicate fibers, hang in a stillness that belies the lively world outside. They are isolated from vibrations coming from nearby roads or distant thunder. Even tiny seismic tremors in the earth are accounted for. These instruments sit in hush and darkness, patiently waiting. They are, in a sense, ears to the cosmos, ears tuned not to sound, but to the subtle ringing of space-time. The sensitivity of these observatories defies imagination. They can detect a change in distance so small that it is measured in fractions of an atom's width. Imagine measuring the distance from one mirror to another, separated by 4 kilometers, and noticing a change smaller than the size of a single proton in an atom's nucleus. Such is the precision required to hear a gravitational wave. It's like being able to tell if a ruler has grown or shrunk by a distance a million times smaller than a grain of sand. With this incredible delicacy, the observatories stand ready to catch the faintest murmur from the universe. There is not just one such detector, but several placed far apart on the Earth's surface. Scattered across continents, these observatories work together quietly. This is important, because a gravitational wave passing through the planet will be sensed by detectors in different locations at nearly the same moment. By comparing the timing, scientists can verify that what they detected was indeed a real cosmic signal and not a local disturbance. With multiple ears attuned, we also gain a sense of direction, much like how our own 2 ears help us pinpoint where a sound is coming from. If one detector hears the faint tremor a millisecond before another, it hints at the wave's origin across the sky. For years, these giant instruments listened without reward. They kept vigil through days and nights, through seasons and years, recording only the hum of earthly noise. Now and then, a distant earthquake or a passing truck would send a shiver through the data. But of gravitational waves, there was no clear sign. It was a long and patient search, as scientists refined the detectors further, dialing down the interference, making them even more sensitive. Some wondered if perhaps these ripples from the distant cosmos were simply too faint to catch, or if we might be listening in the wrong way. Still, the observatories remained focused and ready, like calm sentinels in the dark, confident that eventually a cosmic whisper would rise above the noise. That faith was finally rewarded. On a quiet day, while most of the world went about its ordinary life, the instruments sensed something extraordinary. It was a mere flicker in the data, a tiny, fleeting vibration that lasted only a fraction of a second. To a casual glance, it might have meant nothing, but sophisticated analysis revealed a telltale pattern. It was the signal they had been waiting for, a gentle upward sweep in frequency, often described as a chirp. In that brief moment, the detectors had caught the faint echo of two black holes colliding in the distant universe. The scientists monitoring the instruments realized they were witnessing something extraordinary. There was no roaring applause in that quiet control room, just a shared, hushed awe. Some smiled in disbelief. Others wiped away quiet tears of joy. Years of patience had been rewarded. They had heard the cosmos speak at last, and in that gentle moment, humanity's long wait was over. The news spread slowly at first among the small community of researchers, then rippled out across the world of science with excitement. We had done it. We had heard the unhearable. In a sealed, silent room on Earth, humanity listened as black holes billions of light years away smashed into each other. It was a triumph of patient listening and exquisite engineering. The gravitational wave signal arrived quietly, with no fanfare, but it marked the beginning of a new age of discovery. Scientists double-checked and triple-checked the findings, ensuring that this tiny tremor was real. It matched precisely what Einstein's theories had predicted for such an event. The pattern of the wave spoke of two massive objects spiraling together faster and faster until they merged, releasing a burst of energy as gravitational waves. This first detection proved that our instruments could indeed feel the shake of space-time from across the cosmos. It was hard to fathom. A phenomenon that took place so far away and so long ago had made itself known on Earth through an almost impossibly small effect. But it was real. By hearing this faint cosmic murmur, we confirmed that the fabric of space-time can carry messages to us from events we could never witness with light. We had, in effect, grown a new sense beyond sight or sound, a sense attuned to the vibrations of the universe itself. From that moment on, the cosmos felt a little less distant, a little less silent. In that success, humanity had opened a door to a new way of experiencing the universe. The instruments continued to listen, and soon they would hear more cosmic whispers. Each detection would reinforce the realization that we were no longer confined to observing only the light of the heavens. We could now listen to the universe, and the universe had much to say. When we look up at the night sky, everything we know about the stars and galaxies has come to us through messengers of light and other forms of electromagnetic waves. For centuries, our understanding of the cosmos was built on what we could see or detect with our telescopes: visible light and later X-rays, radio waves, and infrared. These were the cosmic messengers we knew, painting a picture of the universe in brightness and color. But there were always mysteries lurking in the dark, phenomena that emitted no light for us to capture. The collision of black holes is one such mystery, a cataclysmic event completely invisible to traditional astronomy. No telescope, no matter how sophisticated, could directly witness two black holes merging in the void. Gravitational waves have changed that. They have emerged as a new cosmic messenger, one that does not carry light at all, but instead carries information in the form of space-time vibrations. This messenger had been anticipated long ago. Over 100 years in the past, Albert Einstein's theory of general relativity first suggested that space and time could ripple like a pond's surface, and that these ripples would travel outward as gravitational waves. At the time, even Einstein wondered whether such tiny effects could ever be observed. For decades, gravitational waves remained a theoretical whisper, accepted in principle, but seemingly impossible to hear with our limited technologies. In the late 20th century, we gained indirect proof that these whispers were real. Astronomers observed a binary pair of dense neutron stars gradually spiraling toward each other at precisely the rate Einstein's theory predicted, as if invisible waves were carrying away their energy. It was a strong hint that the cosmic whispers existed, even though we had not yet directly heard them. Now, with the first detection of those waves, that theoretical whisper became a clear message. It confirmed that the universe was indeed communicating with us in this new way. Gravitational waves arrived as a messenger from the darkness, carrying news that light could not. They told us, unmistakably, that two massive black holes had collided and merged. In doing so, they opened our ears to an entirely new aspect of cosmic events. This was more than just a new tool for science. It was like discovering a new sense, as if a person deaf from birth suddenly could hear the wind rustling leaves for the first time. Unlike light, which can be blocked by dust or absorbed by intervening matter, gravitational waves travel unimpeded through almost everything. When black holes collide in a distant galaxy, the light from that event might be scant or non-existent, and any that is produced could be trapped behind shrouds of gas and dust. But the gravitational waves from that event will sail right through those barriers, through the intervening stars and galaxies, and eventually reach us. They bring us an undistorted story of what happened, straight from the heart of the event. This makes them precious messengers for understanding phenomena that would otherwise remain hidden. Each form of cosmic messenger, light, particles, and now gravitational waves, tells a different part of the story of the universe. Light showed us the structure of galaxies, the life cycles of stars, and the cosmic web stretching across space. Tiny particles like neutrinos, ghostly particles emitted in nuclear reactions, have also been caught from events like supernovae, adding to the tale. But gravitational waves carry the rhythm of space itself. They let us hear the collisions and movements of massive objects in a way that complements what we see. It is as though we had been watching a cosmic dance in silence all this time. And now, at last, the music has been turned on, even if only at a low volume. The dance was never silent. We just lacked the equipment to perceive its sound. With gravitational wave detectors, we finally have the volume turned up enough to catch the faint notes of that music. The arrival of this new messenger marked the dawn of gravitational wave astronomy. It is a new era in which scientists do not only observe the universe through images and light, but also listen to it through the vibrations of space-time. Every time we detect a gravitational wave, it is akin to receiving a cosmic telegram sent across eons, telling us about a dramatic event in some remote corner of the cosmos. These messages come in a medium entirely different from light, yet they carry equally vital information. Perhaps one of the most profound aspects of this development is that it expands our human experience of the universe. We are no longer just spectators gazing at distant fireworks. We have become auditors of the cosmic symphony. When those first gravitational waves were recorded and translated into sound, scientists and the public could actually listen to a representation of two black holes merging, a literal sound from an event so far away. Hearing that faint chirp from the depths of space made the event feel almost intimate, as if the universe itself had whispered directly into our ear. This new messenger has many stories yet to tell. The first few detections were only the beginning, the opening notes of a much longer composition. We realize that there is so much happening in the darkness. Black holes colliding, neutron stars spiraling together, perhaps other exotic events that were invisible to us before. Each will send its own gravitational wave signals, and with our detectors, we can listen in. We have added a powerful new voice to the cosmic conversation, and it is already reshaping our understanding of reality. In embracing gravitational waves as a cosmic messenger, we acknowledge that the universe communicates in more ways than one. There is a profound serenity in realizing that even in the silent void of space, where sound cannot travel, there is still a form of cosmic music playing. These waves are silent to our ears, yet through our instruments, we can sense their presence and decipher their meaning. It reminds us that the cosmos has depth and richness beyond what we directly perceive, layers of information and beauty that we are only beginning to explore. This messenger from the darkness has arrived on our doorstep, carrying knowledge of things we could never see. It invites us to expand our perception and to find new ways to understand the cosmos. And as we tune into these gentle cosmic vibrations, we prepare to learn more than ever about the hidden workings of the universe. The question then becomes, what stories are these gravitational waves telling us? What can we learn from these messages sent through the darkness? At last, we come to the content of those cosmic messages. Now that we can catch and interpret gravitational waves, what stories are they telling us from the darkness? Each gravitational wave signal that reaches our detectors is like a letter written in a secret language, the language of space-time. Scientists have learned to read this language by analyzing the shape of the wave, its rising and falling tones, its strength, and how it changes over time. From this analysis, a remarkable picture emerges. In the wiggling pattern of a gravitational wave, we can discern the mass of the objects that dance together, how fast they whirled around, and even how far away the dance took place. The first gravitational wave we detected, the one that came with that distinctive chirp, told a detailed story once we deciphered it. In essence, that wave said, "I come from a pair of black holes that collided in a galaxy about 1 1/3 billion light-years from Earth. Each black hole was about 30 times the mass of your sun. They spiraled into each other, completing many orbits in the final second, faster and faster, until they merged into one larger black hole. In that final instant, a portion of their mass turned into energy and shook the fabric of space. I am that shake, traveling outward, bringing you the news." All of that information was encoded in a fraction of a second signal, a subtle vibration that we caught here on Earth. By reading it, scientists confirmed not only that the black holes existed and merged, but also measured their masses and the energy of the collision. It was like listening to a faint echo and being able to tell how large the canyon was that produced it. Subsequent gravitational wave detections have continued to enrich our understanding. One by one, these signals arrived from different corners of the universe, each with its own unique pattern and story. In one case, the waves revealed a pair of black holes of different sizes, perhaps one around 20 solar masses and the other around 35, in a distant galaxy. By decoding the signal, researchers learned how those uneven partners spiraled together and coalesced. In another case, a gravitational wave indicated a merger that produced an extraordinarily massive black hole, far heavier than any we had directly observed before. This told us that black holes of moderate size, dozens of times heavier than the Sun, can merge to form even larger ones, hinting at how the universe might build black holes of increasing scale through successive generations of mergers. Each new detection has been a confirmation that what was once purely theoretical is indeed happening regularly throughout the cosmos. We now know that black hole collisions are not exceedingly rare miracles. They are a natural part of the cosmic life cycle. From the data gathered in just a few years of listening, scientists estimate that in the observable universe, such mergers may be happening somewhere every hour, or even more frequently. The universe is populated with double black holes in cosmic dance, some of which will eventually come together. And when they do, gravitational waves carry the tale of their union across space and time. Through these gravitational wave messages, we have learned about the population of black holes in ways never possible before. For instance, prior to these detections, astronomers mainly knew of black holes by observing X-rays from hot gas around them in binary star systems within our galaxy. Those were often limited to black holes up to perhaps a dozen times the Sun's mass. But the gravitational wave signals immediately revealed black holes twice or three times that mass merging far away. This was a surprise and a delight. It meant there were whole families of hefty black holes out there that we hadn't met until the waves brought news of them. We discovered that some stars, or perhaps previous mergers, had created black holes 30, 40, even 50 times the mass of the Sun, which later found partners and merged again. These insights have prompted new questions about how such big black holes form, questions we wouldn't even know to ask without gravitational wave astronomy. Beyond just masses and frequencies, gravitational wave signals carry hints of other properties. The way the waves oscillate can tell us if the black holes were spinning, and how those spins were oriented as they merged. If one black hole was spinning like a top, and the other wasn't, or if they were tilted at angles to each other as they orbited. Subtle fingerprints of that can be imprinted on the wave. Scientists are still teasing out these details from the data, but with each event, they learn a bit more about the personalities, so to speak, of the black holes, whether they were calm or spinning wildly when they met. In these faint messages, we also find confirmations of fundamental physics. Every gravitational wave detected so far has matched beautifully with the predictions of Einstein's general relativity. The shape of each wave, how it rises, peaks, and fades, aligns with what our best theories say should happen when massive objects collide. This agreement reassures us that our understanding of gravity holds true even in these extreme cosmic furnaces. It's as if, with every new wave, the universe has nodded along to Einstein's century-old melody, each time singing, "Yes, this is how gravity works." Scientists have looked closely for any unexpected quirks in the waves, any slight discord that might reveal new physics beyond our current knowledge. But at least so far, the cosmic dance appears to be playing out exactly on key. That in itself is profound. It tells us that even in the most violent mergers of black holes, nature follows the rules we've discovered with almost unfathomable precision. Not all messages have been about black holes. Gravitational waves have also told us of other monumental events. A particularly historic detection came not long after the first, when our instruments caught the telltale tremor of two neutron stars, the ultra-dense remnants of dead stars, spiraling together and colliding. This event was special. The gravitational waves were detected, and just seconds later, observatories in space observed a flash of high-energy light, gamma rays, from the same direction. Remarkably, the gravitational waves and the light arrived almost together, confirming that these ripples travel at the same speed as light itself, just as theory predicted. Astronomers around the world turned their telescopes to that patch of sky and witnessed the afterglow of the collision. It was the first time we both heard and saw a cosmic event in concert. From the gravitational wave, we learned the masses of the neutron stars and how they enspiraled. From the telescopes, we saw light from the collision's debris, Within that light, we found signatures of elements like gold and platinum being forged in the explosion. In other words, we caught the universe in the act of creating heavy elements and dispersing them into space. This single event answered a long-standing question of where some of the heaviest elements in the universe come from. The gravitational waves were the trigger that let us catch this moment. They truly served as messengers, alerting us to a phenomenon we would have otherwise missed, and giving us the opportunity to witness cosmic alchemy in action. Each gravitational wave message expands our understanding of the cosmos in some way. Some refine our knowledge of how often stars end their lives in these dramatic fashions. Some help pin down the maximum size a neutron star can be before it collapses into a black hole. Others hint at the environments where black holes meet, whether they are born together as twin stars that later become black holes, or they meet in dense star clusters later in life. With every detection, scientists compile more pieces of a grand puzzle, seeking to understand the life stories of these enigmatic objects. The darkness that once hid these events is dark no longer, at least not completely. Gravitational waves have illuminated it for us, acting like a cosmic flashlight revealing hidden dances in the night. Where once we could only infer or speculate about black holes merging in distant galaxies, we can now observe them directly through their gravitational signatures. We have gone from ignorance to knowledge, from wondering if such events ever happened, to listening to them as they occur across the universe. But perhaps the most moving aspect of these messages is how they connect us, sitting here on our small planet, to some of the most remote and powerful events in existence. Think about it. A black hole merger, billions of light years away, can send out a wave that, after traveling through space for billions of years, causes a detector on Earth to move ever so slightly. It is a direct physical connection between us and that distant event. The wave that jostled the detectors ever so gently also jostled you and me, stretching and squeezing each of us by a tiny amount as it passed. We did not feel it, but it happened. This means that when we receive these messages, we are not just learning about the cosmos in an abstract sense. We are literally touched by distant events. We are, in a subtle way, participants in those events, responding to their echoes ages after they took place. Every time a gravitational wave passes through Earth, it's as though the universe itself reached out across space and time to give us a faint, reassuring tap, letting us know about something extraordinary that happened long ago. The messages from the darkness are not just about black holes and numbers and distances. They are also about connection. They remind us that the universe is a network of events linked by these traveling ripples. We are connected to the farthest galaxies and the most energetic happenings through the fabric of space-time itself. This realization brings a new perspective. We find that knowledge of these cosmic collisions does more than satisfy curiosity. It deepens our appreciation of our place in the universe. The next time you look up at the night sky, you might remember that even as it seems tranquil and silent, it is anything but still. Invisible waves are passing through you, through all of us, bearing witness to the ceaseless activity of the cosmos. They are a testament to the dynamic, ever-changing nature of reality at the grandest scales. As we continue to listen to these messages from the darkness, we will undoubtedly learn even more. Each new wave that gently washes over Earth will bring fresh details about the universe's hidden corners. We stand at the beginning of this new way of knowing. It's a bit like standing on a shore at night, listening to the far-off roar of waves breaking on a distant, unseen coast, gradually realizing the lay of the land from the sound alone. Piece by piece, wave by wave, the dark unknown becomes more familiar. Through these cosmic messages, we have illuminated phenomena that were once purely speculative. Black holes, those enigmatic objects that not even light can escape, have effectively spoken to us through gravitational waves. Neutron stars have revealed their dramatic final embrace. With each revelation, we refine the story of our universe's workings. What we learn from gravitational waves doesn't remain remote and academic. It flows back into our understanding of everything, including the world we inhabit. We now know that the gold in our jewelry was likely forged in collisions like the one we heard. We know that black holes can grow by merging, influencing how galaxies evolve over time, since many galaxies harbour giant black holes at their cores. Little by little, the knowledge gathered from these faint signals is woven into the tapestry of cosmic history that we strive to understand. The messages from the darkness have affirmed much of what we thought, surprised us with things we hadn't expected, and connected disparate parts of physics, astronomy, and cosmology into a more unified story. They have answered questions and raised new ones. And beyond the scientific insights, they have given us something profoundly human, a sense of wonder and a deeper connection to the cosmos. Armed with this new sense of hearing, we can look out at the night sky and feel that we are finally attuned to the full grandeur of the universe's events, not just the ones we can see. With each gravitational wave detection, our sense of belonging in the cosmos grows stronger. We find ourselves linked to the cosmos not just by the light we see or the ground we stand on, but by the very fabric of space that binds us to distant stars. In understanding these messages, we take a step further in answering that age-old question: what is our place in all of this vastness? The answer unfolds gently as the cosmic messages keep coming in. They tell us that our place is not as outsiders looking in, but as intrinsic parts of the grand cosmic dance, connected through invisible strands of gravity and energy. And it is this thought that naturally leads us to reflect on our own role and presence in the universe, our place in the cosmic dance. When we pause to reflect on it, the simple act of listening to these cosmic whispers has changed how we see ourselves. We have become part of the cosmic dance that we once only observed from afar. In learning to hear the faint waves from merging black holes, humanity has stepped into a new role, not just as onlookers in the vast universe, but as participants in its grand story. We have tuned our senses beyond our little world, extending our reach out across the cosmos. In doing so, we have forged a connection between our planet and events happening billions of light years away. Consider the almost unimaginable chain of events that leads to this connection. Long ago, in a galaxy an unfathomable distance from here, two black holes collided and merged. At that time, Earth was perhaps home to simple life forms swimming in ancient seas. Our earliest ancestors were still yet to appear. As those gravitational waves set out on their journey, the universe continued its evolution, and on Earth, life slowly grew more complex. Ages passed. Dinosaurs roamed and then vanished. Mammals rose. Humanity eventually emerged and began to wonder about the stars. All the while, that ripple in space-time was racing across the silent expanses, carrying the news of the black hole's dance. By the time it reached Earth, we had only just invented instruments sensitive enough to notice it. It's as if the universe had sent out a message eons ago, and we emerged at just the right moment to receive it. This realization gives one a shiver of awe. Our existence and our curiosity aligned with the echoes of an ancient cosmic event. bridging an immense gulf of time and space. This sense of timing and connection speaks to our place in the cosmic dance. We are not separate from the cosmos. We arose from it and are woven into its fabric. The iron in our blood was forged in the core of a long-dead star. The calcium in our bones was brewed in stellar furnaces, and the gold in a ring on your finger may well have been created in the cataclysmic merger of neutron stars, an event that also sent gravitational waves sweeping through the universe. In a very literal sense, the matter that makes up our bodies and our world has participated in cosmic events. Now, through gravitational waves, even the space we inhabit participates in cosmic events as they happen, trembling in sympathy with distant catastrophes. Knowing this fosters a profound sense of unity with the cosmos. When we detect a gravitational wave, it's not just a scientific triumph, it's a moment of communion with the universe. It is evidence that the separateness we often feel is, at some fundamental level, an illusion. We are connected by threads of energy and gravity to everything else. When two black holes collide halfway across the universe, the fabric of space that we share with those black holes quivers, and for a brief moment, we all dance together. In that instant, across unimaginable distance, there is a meeting of our existence and theirs. Such a perspective can be deeply comforting. The universe is vast beyond comprehension, and it's easy to feel tiny and insignificant in the face of that immensity. But recognizing that we have the ability to perceive these distant events, to be aware of them and learn from them, gives us a sense of belonging in the cosmos. We may be small, but we are not irrelevant. We are the part of the universe that can reflect on itself, that can admire the grand cosmic dance, and even gently join in by responding to its rhythm. Our minds, curious and seeking, are as much a product of this universe as the stars and black holes. In listening to gravitational waves, we are, in a way, allowing the universe to know itself through us. Our place in the cosmic dance is also one of responsibility and hope. The very fact that we can detect these whispers means we have reached a level of sophistication and knowledge that is unique. We have unlocked one of nature's secrets. With this knowledge comes the duty to preserve it and pass it on. Achieving this feat of listening to the cosmos was not the work of one person alone, but of many minds and hands across the world. Scientists, engineers, and dreamers from different countries and backgrounds came together, sharing a common goal. For decades, they collaborated quietly, pooling their expertise to create those marvelous detectors. This global effort reminds us that when humanity unites in curiosity and purpose, we are capable of incredible things. Under the common sky, differences fade, and we become simply people, all listening for the same whispers from the stars. In this sense, our place in the cosmic dance is also shared collectively. We dance together as one species, in tune with the universe. Humanity's relationship with the cosmos stretches back long before we had science or technology to measure it. Our ancient ancestors looked up at the night sky with curiosity and awe. They saw patterns in the stars and spun tales about gods, animals, and heroes placed among the constellations. Under the same sky that we now study with detectors and telescopes, They felt the mystery of existence and wondered what those distant lights might be. In a way, they were dancing too, through stories, rituals, and observation, trying to connect with the universe beyond. That enduring wonder was the seed of our modern exploration. Over millennia, as our understanding grew, we never lost that fundamental sense of amazement. Every generation built upon the knowledge of the previous, from figuring out the motions of planets to discovering the laws of physics that govern the stars. The ability to detect gravitational waves is the latest step in a very long journey. It's as if those early sky gazers, who could only imagine what the heavens were, have finally found a new voice from the stars. If they could see us now, listening to the universe with exquisite instruments, they might smile, knowing that their wonder was not misplaced. We have, in our modern way, continued the age-old human quest to learn our origins and our place. Think of the Earth itself in this context. Our planet is not only our home, but also a tiny dancer in the cosmic ballet. Earth orbits the Sun orbits the center of the Milky Way, and the Milky Way drifts among countless other galaxies in the expanding universe. These are slow, majestic movements, a waltz of worlds and galaxies over millions and billions of years. Gravitational waves add another layer to this dance. When they pass by, Earth ever so slightly bobbles in its steps, responding to a distant partner's call. It's a reminder that even as we go about our daily lives, our planet is engaged in this intricate choreography set by gravity. Picture yourself on a clear night, standing under a dome of stars. The Milky Way may arch overhead as a faint band, a gentle river of starlight across the sky. In the stillness, you might feel alone, a single person on a small planet under an enormous expanse. But now imagine, as you gaze into that darkness, that all around you, the fabric of space is alive with faint ripples. Those ripples are carrying memories of stars that exploded and fell into black holes, of binary stars that spiraled together, of cosmic events that occurred when life on Earth was just beginning. They are so gentle that they pass through you without any sensation. Yet, through the ingenuity of our minds and tools, you know they are there. In that moment, you might feel a subtle reassurance, a sense that you are not just looking out at the universe, but that the universe is also reaching out to you. Softly, invisibly, but really and truly reaching out. This realization can transform our relationship with the night sky. The silence of the night is not the silence of absence. It is the silence of hidden activity, of life and death on a scale far beyond our human concerns, continuing regardless of our awareness. Now that we have learned to listen a little, the night becomes more comforting. The stars still shimmer with their distant light, but now we also imagine the quiet ripples passing through, carrying news of cosmic events. It's as if the cosmos is telling us stories as we fall asleep, stories we are only just beginning to comprehend. The mysterious and relaxing tone we feel while contemplating these matters is no coincidence. There is something inherently soothing in recognizing one's part in a larger whole. All the anxieties and noise of daily life can, for a moment, fade into the background when you think about gravitational waves gently undulating through you. The scale of it all puts things in perspective. While we tend to our individual lives, the universe flows along as it has for eons. In spite of the vast difference in scale, here we are, aware of that flow. It can bring a sense of peace, knowing that there is an order and continuity to the cosmos, and that our knowledge has extended to touch it. As we step back and look at the journey we've taken, from imagining the collision of black holes, to following the path of gravitational waves, to capturing those waves and extracting their secrets, and finally to feeling our connection with these distant events, we see a tapestry of curiosity and discovery. It is a story of humans reaching out with their intellect to touch the stars, and finding that the stars and black holes, in turn, touch us back, through physical laws that bind us all. This mutual touch is gentle, yet profound. It tells us we belong in this universe. We are a part of its story, not just observers, but participants, influenced by and influencing it, even if only by unraveling its mysteries. Looking to the future, our role in the cosmic dance will likely grow. The observatories we have now are just the beginning. Plans are already underway for new instruments that will listen to the universe in different ways. Some will be sent into space, free from the noises of Earth, to detect gravitational waves that are too slow or subtle for our ground detectors. Waves perhaps from the dance of supermassive black holes, each millions of times heavier than the Sun, as they merge at the centers of distant galaxies. We may one day catch the ripples from the very early universe, echoes from the time when the cosmos itself was newborn. Imagine hearing the faint impression of the Big Bang's aftershocks, or capturing signals from the first stars collapsing into black holes. These would be messages from a time before Earth existed, from an era utterly alien to us. Yet they would connect us even more deeply to the origin and evolution of everything. With each advancement, we extend our participation in the cosmic story. We will not only listen, perhaps in the far future, we might even learn to send out our own gravitational wave signals intentionally, though for now, that idea remains in the realm of imagination. For the present, our task and our joy is to keep listening and learning. There is a serenity in that pursuit, a quiet dedication to understanding the cosmos. And so, our place in the cosmic dance is both humble and exalted. Humble because we are small and our influence on the cosmos is negligible. The universe would carry on dancing whether or not we were here to witness it. Exalted because we have the privilege to be conscious participants, rare and perhaps unique in our ability to appreciate the cosmic ballet unfolding around us. It also reminds us how precious our vantage point is. We live on a small blue planet, a fragile oasis suspended in the infinite dark, yet from here we can gaze out and understand so much. Our world may be tiny, but it is a cherished part of the universe, the cradle from which we reach for the stars. It is often said that we are made of stardust. In a poetic sense, that is true. The atoms in our bodies were forged in stars long ago. Now we can add that we have danced to the rhythm of black holes. When a gravitational wave passes, every fiber of our being moves to that ancient rhythm, if only by an atomic whisper. We have always been dancing, even when we didn't know it. Now, having heard the music, we can dance consciously, celebrating our connection to the cosmos. In the quiet hours of the night, when you find yourself under a sky full of stars, you can feel this connection. You can imagine the silent waves washing through you, and know that you are being gently rocked by the universe's tide. You are on a tiny boat, the Earth, in a vast cosmic ocean, and far away, other boats, Stars, black holes, galaxies create ripples that eventually reach you. It's a calming thought. The universe is not a cold, distant expanse, but a sea of activity in which we are immersed, and which even now subtly touches us. As our journey through the dance of black holes comes to an end, think of what we've uncovered. We have witnessed, in our mind's eye, the spiraling union of black holes in remote darkness. We have felt the resonance of those unions crossing the cosmos. We have realized that through science and curiosity, we extended our senses and found a new way to engage with the universe. We stood in awe of how well our theories explained these phenomena, and in even greater awe of the sheer scale and power of what those waves represent. Finally, we have turned our gaze inward to see how this knowledge changes us. It fills us with wonder, with humility, and with a gentle sense of connection to all that is. This is a fitting and gentle conclusion to our exploration. The cosmic dance will continue, eternally playing out in the grand halls of space. Black holes will collide and merge. Stars will be born and die. Galaxies will swirl in their graceful motions. Through it all, gravitational waves will ripple outward, carrying the news of each event. And here on Earth, we will be listening, quiet and attentive, like someone listening to distant music carried on the breeze. We conclude now with peaceful hearts, knowing that the darkness of the sky is not empty, but full of stories and movements. The next time you feel the stillness of midnight around you, remember that you are enveloped in the faint music of the cosmos. That thought alone can be as soothing as a lullaby. It's the universe's lullaby to us, a reminder that even in the deep silence, we are not alone. We are part of an immense, mysterious, and beautiful universe. So, take a deep breath and feel the calm of that knowledge. Under the ancient starlight, let yourself be lulled by the idea that you share in the cosmic dance. Every beat of your heart and every ripple of space-time is part of the same grand tapestry. Though our journey through these particular stories has reached its end, the cosmic dance goes on, and we remain a part of it, always connected, always listening, and always in wonder. Good night, and may the stars and the whispers of the universe watch over you gently